Started, ma'am.
Okay, so very good. Good afternoon to all participants in the 11th session of the sixth day of AICT sponsored Atal FDP on AI powered urban futures, advancing sustainability in smart cities. We have today's speaker with us, Dr. Manish Kumar Goyal. He is Chair Professor and Dean of Infrastructure Development at IIT Indore. He has served in Niti Aayog Consultation Group of Water Management and Climate Change. He worked as a consultant for several prestigious works of IWAI, MPWRD, MPUDC, IMC Indore, Cantonment Board, MFO, NIDM, and UPPWD, etc. He is recently featured in the list of top 2 percentage scientists in the just a minute.
Thank you, madam. Should I start
Yes.
now?
Sir. Uh, he is recently featured in the list of top 2 percentage scientists in the world in 2020, 2021, 2022, 23, 24, and 25. His research interests include construction, finance, wetland, environmental, agriculture, climate, water, artificial intelligence, and GIS and RS applications. He worked as research assistant at University of Waterloo, Canada. He went to pursue further research at postdoctoral fellow at Nanyang Technological University, Singapore, and McGill University, Canada. He was visiting professor at University of Nebraska, Lincoln, USA, and Aristotle University of Thessaloniki, Greece. Dr. Goyal holds 8 books, 35 books, chapters, and more than 150 technical research publications in various referred journals. He serves as an associate editor for the ASCI journal Hazardous, Toxic, and Radioactive Waste. He has supervised 10 PhD and 8 postgraduate students in last 10 years. His contribution fetched him a recipient of Professor S.N. Gupta Memorial Lecture Award, Indian Society of Hydraulics in 2021, Best Researcher of the Year Award in 2020 by Institution of Engineers India, American Society of Civil Engineers, Environmental and Water Resources Institute, visiting International Fellowship VIF in 2019, Professor R.J. Garde Research Award, India India Society of Hydraulics in 2019, recipient of American Society of Civil Engineers ASCE Best Theoretical Oriented Paper Award in 2018, NV IDEA GPU Research Grant in 2018, IEI Young Engineers Award in Civil Engineering Division in for 2017-18, and Indo-US Wari Fellowship Award in 2016, DST Serve Young Scientist Fast Track Grant in 2015, Inspire Faculty Award in 2014, Amer Eramus Mundus Interview Award Europe in 2014, JSPS Fellowship Award, University of Tokyo, Japan in 2013, and Canadian Commonwealth Scholarship Award. He will enlighten us with his knowledge on IoT and AI synergy in urban infrastructure. Uh, so, सर मैं तो थक गई बोलते बोलते आपके इतने
Thank
सारे
you, madam.
अवार्ड्स.
Thank you. Thank you.
थैंक
Thank you
यू
so
सर.
much for nice introduction, madam. Now, if you permit, I can start.
Yes sir, yes sir.
Thank you.
हाँ
Thank
सर.
you so much. Thank you very much for the madam and sir for calling me. And I'm very delighted to be here. And I think I'll speak something first, and then we will have a you can have some questions, comments, and we will have discussions. Okay, so I'll speak first on water resources management and drought resilience, and how we can use IoT and artificial intelligence in urban environment. So that is the title given to me. So we will understand this title in context with water management and drought resilience. Okay, and why this is a very important topic in terms of urban environment or even in the terms of rural environment or across the India. So if I talk about India, in India we have like 1.4 billion populations, and like, or I can say around 18% population of all the birds lives in Bharat or lives in India, and we have only 4% of water resources and 9% of arable lands. With 4% of the water resources, 9% of arable land, and we need to feed almost 20% of the bird population. And with this 20% of the bird populations, so this will include basically both rural and urban. And if you see the context in last 4 decades, urban population has been continuously increasing from 1950s onwards to 1990 to 2021. People are shifting, people are migrating from rural to the urban in terms of better opportunities, better jobs, better education, better health, or even better drinking water facilities. So, if I talk in terms of rural and urban settings or in terms of water resources, and in India, the rainfall is highly unevenly distributed. If I talk in terms of spatial temporal rainfall, if you have in western part, if you talk about the urban areas, western part of India, you have a Jaipur, Jodhpur, many cities of Gujarat. Then you have uh, in Telangana, many Arab Hyderabad and Rayalaseema, many cities. You have a Bundelkhand region where there is a scanty of the rainfall. You have a rainfall of 20 centimeters of the rainfall, 30 centimeters of the rainfall, 40 centimeters of the rainfall. So this kind of rainfall is there in these urban areas. And if you see another parts, northeastern part of India, you have a Guwahati region, Shillong region, or even you talk about Western Ghats, many cities, they have a high amount of the rainfall, 200 centimeters of the rainfall, 300 centimeters of the rainfall, 400 centimeters of the rainfall. So this kind of variation exists between these cities. They are located in desert regions, arid regions, or those are located in terms of humid regions like western parts or northeastern parts. In addition to that, these cities have a huge pressure of population, huge pressure on the water resources, huge pressure on sanitation, huge pressure on sewage treatment plants, water treatment plants. All these kind of pressures are there, and how we can manage these pressures. In addition to these pressures, if you remember the events that happened in July 2005 in Mumbai, there was almost more than 90 centimeters of the rainfall in 24 hours. Whole city was standstill for almost couple of hours or couple of days. So these kind of urban issues are there. High extreme events phenomena has happened in Mumbai, and in these events, how we can have the use of IoT or artificial intelligence, and such kind of extreme events are more frequently occurring after that. If you remember Chennai flood events 2019, Kerala flood events, and then we have flood in Kashmir, Srinagar. So all these extreme events has been occurring under the climate change. So this climate change is also putting an additional stress. So whatever stress we have already in terms of urbanization, in terms of population, and there's one more stress is coming of the climate change, and how this climate change, in addition to the existing problems, will impacting our water resources, will impacting our urban systems, will impacting our own lives, social aspect, economical aspect, environmental aspects of sustainability. So that we would like to see. So first of all, we need to understand, because these of all these impacts of the climate change are affecting heat waves, are affecting the cold waves, are affecting the extreme events in terms of drought, in terms of floods. So whether any kind of things is happening in terms of temperature or in terms of rainfall, that if I will give you some kind of an examples, let's say what happens the temperature in last 15 years or last 20 years, what happened to the rainfall, average annual rainfall in last 20 years. So we will try to understand what are the trends across the India in different parts of the cities or different parts of the towns across the India, in whether urban localized or many other parts. So if I talk one more stuff of flood, almost 15% of India's geographical area is subjected to the flood disasters. And many people, around 33 million people, have been affected by the floods from 1953 to 2000. Another aspects I will give you, like many cities, if you have Banaras city, you can take water from the rivers, or many cities which are not located near the river or near the surface water bodies, or they where water has to be lifted from one place to another place, like Bangalore or even Indore. So many people are using the groundwater, and groundwater level are continuously decreasing. Few years back or few decades back, where we are getting the water on 100 feet and 200 feet, now water level has gone down to 500 feet or 1000 feet. This is also creating another problem, because once you go down deeper in the aquifers for more than 500 feet or 1000 feet, you have several problems of heavy metals, geological problems, other problems will come up in terms of water quality. So people, those who are living in urban areas, they are also affected with respect to groundwater qualities. So in India, if you see the multifaceted geography, when I say multifaceted geography, what is the meaning of it? The meaning of it is very clear. In northern part of India, if we take our cities, if we take our urban systems, they have snow, they have glaciers, they have a high perennial rivers. We talk about uh, bigger cities. So these are the stuff. If I talk about the peninsular part of India, you have a more than 7,000 kilometers long coastal line. In the coastal line, you have salination problems. If you talk about the Visakhapatnam, Chennai, or many other cities. So these kind of problems are there. In western part, you have a desert problem. Northeastern part, you have a high rainfall regions. In central part of India, if you talk about Bundelkhand, another drought-prone regions. So this is a multifaceted geography of India, and water resources, they suffer not only their urbanization impact, not only population, water quantity, water quality, but also the climate change impact. And each of these river basins have its different, different aspects in terms of industrialization, population, and many other. What we have done it here, we try to get the data of IMD, and try to find out what kind of patterns are there in terms of annual precipitation or mean precipitations. Whether the rainfall has been decreasing in last 15 to 20 years. So here is the data of 2000 to 2015. And if you compare this data of 2000 to 2015 with data we have from IMD from 1901 onwards. So last 100 years of data, if we compare with that, there is some kind of dry years have been observed in the recent past. So when I say dry years, it means there is a deficiency of the rainfall in those years. And there is another study where they mentioned that in many of the river basins, number of rainy days have been decreased while the number of intense events have been increased. So in India, we are facing this problem because we'll get monsoon for 3 months or 3.5 months. In the 3.5 months, we'll get hardly 30 to 40 days of the rainfall is there. So we have a rainfall of 30 to 40 days, and as a human being, or even as an agriculture, or even as a industrial settlement, we need a water on daily basis. So we need a water on daily basis. We have rainfall only for 30 to 40 days. How can I resolve this problem? So this is a model of 10 raised to 1 problem. I have only for rainfall for 30 days or 40 days or 45 days, and then I need to have the water for all the 365 days in a year. What are the measures? What are the attempts? What are the kind of artificial intelligence we should use in order to have a storage, in order to have some kind of harvesting, in order to conserve the water, in order to preserve the water for the post monsoon period, post winter period. So that's another challenge we have in terms of rainfall. So once we have clear rainfall, what are the temperatures? Are the temperature going up or temperature going down? So if you see this map of maximum temperature and minimum temperature, so in the 2000 to 2015, this is the annual average annual, and this is the for minimum temperature. So minimum temperature and both maximum temperature from the year 2000 to 2015 in compared to 1951 to 2014, they have been increased. So both temperatures have been increased. Another study says that national average annual temperature that's showing a warming around 0.22 degrees Celsius per decade. So per decade, you are getting around 0.2 degrees Celsius. And so I think last week there was a report from WMO, World Meteorological Organizations. They say that 2024 was the hottest year till till date. So whatever the recorded time is there till date, this 2024 was the hottest year.
Sir, we are observing that every year is the hottest year
Sorry,
from
yeah,
last.
somebody's asking question.
Sir, I'm saying that from past 2 years, we are observing that every year is the hottest year. So in 2025, we'll find that 25 is the hottest year. In
2025,
2026,
I have no idea. 2025 maybe the hottest year, but 2024 as per WMO report was the hottest year.
yes, sir.
Yeah, 2025 is yet to go. We are only in the first month of the 2025. So let us see what happens in 2025, whether it will become hottest year till date or not. Should I go ahead?
Yes, sir. Yes, sir.
Okay. So once we have seen the maximum temperature, average maximum temperature, and average minimum temperature, so we try to identify the average temperatures or mean temperature. So mean temperature has also gone up little bit of 0.2 degrees Celsius in last 2000 to 2014. So last 15 years of data. So rainfall has decreased, maximum temperature has increased, minimum temperature has increased, and average temperature has increased. So now we are building little bit slowly our understanding on the various meteorological parameters, how they are behaving in the past 100 years or past 70 years across the India. Okay, so once we have this understanding, we will also touch about 2 3 other aspects. One is the river runoff, because many of these cities are getting the runoff, getting the water from the river. And if there is a decrease in the river runoff, these cities will suffer the water scarcity. I'll give you an example before I go ahead. Like Indore. Indore is getting water almost 490 MCM or around 500 MCM water from Narmada River. Many other cities are getting water from various cities, like Bangalore is getting water around 50 kilometers or 70 kilometers away. So, how the impact of river runoff is happening? Whether the river runoff is increasing, whether river runoff is decreasing. So, what kind of river runoff is there? So, if I talk about the Himalayan rivers, in Himalayan rivers, if you talk about the Western Himalayan rivers or Eastern Himalayan rivers, so in the Western Himalayan rivers, there is a declining trends uh, have been observed in last 41 years for Sutlej river basins at various gauging locations. If I talk about the Eastern Himalayan rivers, like you so talk about Brahmaputra, there are several instances or several incidences where the flood occurrence have been recorded. It means the river runoff has been increased. But also we need to remember that Brahmaputra river, because of a transboundary river, there are many dams on the upstream sides. So it's kind of a regulated flow. Uh, that perhaps will be the reason to increase in the particular number of flood occurrence. And also in the Ganga, Brahmaputra, and Meghna, that's whole basin where we have a maximum population lies. The long-term mean runoff is expected to increase in various 30% to 40% in the end of the century. So that portion is a probably stream flow is increasing. But if you talk about peninsular part of India, where you have a different kind of a river, Narmada, Mahanadi, Godavari, Kaveri, and Krishna. Here is an example given for Mahanadi rivers. So Mahanadi rivers in peninsular India, steam flow rates have been decreased. And steam flow rates have been decreased. It means it will have quite significant effect on the urban systems or urban rivers, those who are getting waters from these Mahanadi river basins. So this is to give you an idea how these rivers runoff has been affected in last 30 years or 40 years, depending upon the data that is available at CWC gauging stations for various rivers. Okay, another thing very important comes of the drought, because India being an agriculture economy, India once being an agriculture economy is around 40% or 45% population is directly and indirectly engaged in terms of agriculture or agriculture related activities. So it is very important for all of us to understand what kind of droughts are occurring and how long they are there in terms of temporal and what kind of a spatial extent are there. So there are few studies which says that around one third of geographical area, like 13-14% is prone to flood. So here they say around 33% of area India is prone to the drought conditions or is subjected to the drought conditions. Drought is nothing but the deficiency of the rainfall, or you have lesser rainfall that year, so we'll say it's a drought. And drought has many parameters that can be measured by SPI, SPEI, or whatever it is. So we can take any of the parameters, and based on that, it's for a few days to few weeks to few months, whatever time is there. And it is not a recent occurring phenomena. This has been occurring since last 5 decades. Because again, many, like in 1960s, year 1965, then you have a 1972, 1979, 1987, 2009, 2016, and 2022. All kind of these years, the drought has occurred in many parts of India, and few parts they have suffered more, and few parts they have suffered less. So one of the study that has been carried out at 566 stations across the India that you see in a triangle shape in this map, to assess what kind of meteorological droughts are there. Meteorological droughts is nothing but the deficiency of the precipitation. Then you have a agriculture drought, hydrological droughts, soil moisture droughts, vegetation drought, and then you have a socio-economic droughts. So there are 4, 5, or 6 types of the droughts depending upon the type of the problem you have in your hand. Which kind of problem you are addressing, whether you are addressing the socio problem, whether you are addressing the farmer problem, or whether you are doing a kind of a meteorological analysis of the various data across the region that you have in your plate. So in this particular study, drought conditions across 566 stations from IMD data has been taken, and this was assessed using SPI, Standardized Precipitation Index, of 6-month series using the monthly rainfall data. And the trends has been find out in terms of average drought duration. You know what kind of average drought duration is there in terms of weeks or in terms of month, and what kind of severities are there. So severity may be less or higher at some other places. So this kind of a study has been carried out for various parts of India, and using the data of almost 100 years, 102 years of data from 1901 to 2002. So if you see in the map, there is an increasing trends has been occurred at northeastern parts, central eastern part, and southern part of India, and decreasing trend has been occurred in the western, northwestern, and southern region of India. And these are the all 566 stations are like district stations of urban areas where such type of the data of precipitation has been taken into the account. And in urban areas, you can find out which are the more vulnerable urban areas and which are the less vulnerable urban areas. So more vulnerable urban areas are, you can find out here in this part. They have a significant increasing trends in terms of drought, and this is located in another peninsular part of India. This is also located on this place. So basically the concentration lies at 1, 2, and 3 place. Rest of India is not very significantly either increasing or decreasing. So that kind of a study will give us that how in an environment, in a given urban environment, we have a drought conditions are prevailing or not, or whether what kind of trends are there in last 100 years. They are going up or they are going down, so that we can make some kind of a arrangement in terms of either better weather forecasting, so that we can have the proper arrangement, so that we can get the data in terms of sensors and others, and we can manage for the that drought period of that region of urban areas. So this is for the drought. Yeah, any of the study of, if I talk about urban environment, will not be completed without the glaciers. without the glaciers. It means India is around more than 9,000 glaciers, and many of the glaciers are melting. And these glaciers are melting, and they are contributing water to the many rivers, especially in the rivers which are originating from northern part of Himalayan region, western part or eastern part, both of the Himalayan regions, in terms of Brahmaputra, Ganges, or Indus, in all these three rivers. And the evidences are there that long-term mass balance, if you do of the various glaciers, there is a net loss for the glaciers in the last 4 decades, bearing a few. Here, an example they have given that the rate of the glacier is around 0.2 to 0.7% in Indian Himalayan region for 11 river basins. And if you see the Chota Sigri glaciers, there is a net loss of around 1,000 meters over 2002 2009. And also, there is one more study has been carried out because this
Yes, sir. What happened? Any issue?
वो लग रहा है गोयल सर के वहीं से उनको इशू हुआ है और नेट डिस्कनेक्ट हो गया उनका.
Okay.
All participants, please fill the attendance form. We'll close the attendance form today by 8 p.m. Uh, and one more information for you all. After today's session, uh, you all have to fill the feedback on Atal website. When you open login to Atal website, I can share you the screen if you all wish to. Atal portal. So feedback has to be filled on the Atal portal itself, and it is mandatory for all to fill the feedback. किरण मैम, are you there?
Yes, sir.
मैम एक श्रीनिवास सर की भी अटेंडेंस लगी नहीं है मैम.
श्रीनिवास सर की
हाँ मैम,
एक मिनट मुझे व्हाट्सएप कर दो, मैं अभी देखूंगी थोड़ी देर में ना.
मैंने कर दिया मैम. मैम
हाँ
आप
हाँ
देख लीजिएगा. ठीक है मैम.
हाँ.
मैम कॉल कर लो एक बार वहीं से वो
मैं
लोग.
ही इज नॉट पिकिंग द कॉल.
ओके.
hello, can you hear me?
यस सर.
Okay, I think there was some kind of a change.
Yes sir, yes sir.
यस सर.
Okay, so now should I go ahead?
यस सर.
So just share the screen, sir.
Okay. So, there is a internet problem from my side or?
Sir,
I
here
think
all
your
are
side,
clicking.
from your side.
Okay. Sorry. So, can you see the screen?
Yeah.
Yes sir, definitely.
Okay, thank you. Okay, so now we have a little bit idea of rainfall, we have idea of temperature, we have idea of runoff, we have idea of drought, and we have an idea of glaciers. What's happening, all these different aspects of meteorological variables across the India. And now we have another variables called climate change. And because of this climate change, we have a many kind of extreme events. We have a changes. And India being a developed country, and so if there are stresses on water resources, it will impact whole the fabric of socio-economic aspects. Because being an agriculture economy, our GDP or our contribution in terms of employment will come from uh, will come from agriculture economy. So what the people have done, or what the policymakers have done to understand this impact, first of the national water policy that has come in India in 1987, and then there was change in 2002, and there was change in 2012. And I think 2022, they have published one kind of a draft of national water policy, where they talk about uh, uh, IoTs and AI use in terms of water resources sectors. So, this being a very important factor of national water policy under the climate change. Climate change. Another important aspect that we have will talk about is the land use cover, change in the land use and land covers. So this change in the land use and cover is happening because people are migrating from rural to the urban, and the whole watershed or whole the river basins, it changes from rural to the urban sheds. And once it changes to the rural to urban sheds, whole the topography changes, whole kind of water resources changes, percolation changes, evaporation pattern changes, and this will impact the whole hydrology of the basin or the discharge of the basin. So this is another aspect. So to combat these problems of flood, drought, glaciers, climate change, what we need to do? We need to have a first is the good quality data. Somewhere, if you get the data in many places, you will find so many zeros in the rainfall regions, and so doing the probability distribution becomes much more difficult. So what we need to do, we need to have some kind of a good quality data. Once we have good quality data, it should be accessible to all. It means it should be distributed to all the stakeholders freely. Then we need to upgrade the data collection networks. It means we need to upgrade the more monitoring stations so that we'll get the accurate data at different locations. And being these problems of different kind, it's not a single discipline problem. It's a multidisciplinary research problems in different parts of the country. So this will require some kind of a teams of various experts and various pupils. They will assess in terms of scientific decisions of water, climate policy, and how we can take the IoT and AI in terms of climate change. Okay, so I'll take a case study of drought years and their uses in terms of remote sensing and GIS. So that's a part of artificial intelligence. So I'll take one case study so that you will understand much better of the drought conditions. So drought, we have already defined the droughts, deficiency of the precipitation, that we say drought. Here I'll take an examples of 22 river basins across the India. And this classification is as per CWC, Central Water Commission. And you can see this, the first, this is the Indus River Basin. And then you have 2A. This is Ganga River Basin. This area is around 8.5 lakh square kilometers. This is like 4.5 lakh square kilometers. And then you have 2B and 2C. They are the Brahmaputra River Basin, around 2 lakh square kilometer. 2C, that's around 40,000 square kilometers. And then you have a third one, this is the Godavari River Basin, 3 lakh square kilometers. Fourth one is Krishna River Basin, 2 lakh 60,000 square kilometers. And then you have a Suvarnarekha, Brahmani and Baitarni, Mahanadi, Pennar, Mahi, Sabarmati, Narmada River Basin, Tapi Basin, best flowing rivers of South Basin, and these are the east flowing rivers between Mahanadi and Godavari and Krishna and Pennar and Kaveri. And there are east flowing rivers of Kaveri River Basin, and then the west flowing rivers including Saurashtra, including Muni Basin, 20. So this is a kind of general descriptions of the 22 river basins that we are going to consider in this study area. Okay, what kind of data sets we have taken of in terms of to compute the drought efficiencies or agriculture water use efficiencies for using the AI. So net primary productivity is the one of the data that we have taken from NASA Earth Observation Satellite programs, and the spatial resolution is 1 kilometers. Then we have evapotranspirations. Then we have NASA data of Earth observation system. That's another 1 kilometers. Then we have a land cover classifications from USGS web page of land cover institutes. That's around 500 meter by 500 meters. Then we have a Koppen Geiger climate classifications of climate research unit of University of East Anglia, 0.5 degree by 0.5 degree. Precipitation data from Indian Meteorological Department 0.25 by 0.25 degree. Temperature data from Princeton University 0.25 by 0.25 degree, and solar radiations NCP NCR data 0.3 degree by 0.3 degree. So these 7-8 data types we have used in order to compute the drought resilient in terms of AI. And this map probably you may have seen if you are all have studied the engineering hydrology in BTech third year. So this is the map. We have a mean annual precipitations that's across the river basins. So you'll find out that we have a maximum annual precipitation somewhere in the northeastern part of India and Western Ghats, and you have a very deficient rainfall in the western part of Rajasthan and part of Telangana, Rayalaseema, and Bundelkhand regions. So this is a mean annual precipitation over India, and you can find out the different boundaries of various river basins. Okay, if you remember, I told you one word, the primary productivity term we have used. So what is the meaning of productivity? So let us understand the productivity first and then we can go ahead. Productivity is nothing but the rate of generation of biomass in an ecosystem. How much rate we are generating in a biomass in a given ecosystem. That is known as productivity. And productivity, there are two types basically, primary productivity and secondary productivity. Productivity of plants or productivity of autotrophs is known as primary productivity, and the productivity of the animals or heterotrophs, they are known as secondary productivity. So here we are talking about the primary productivity only. It means the mass of the carbon generated in a ecosystem. There we will talk about the productivity. So primary productivity, this is nothing but the synthesis of organic compounds from atmospheric and aqueous carbon dioxide. And basically, if we talk about terrestrial ecoregions, there are mainly plants, while in aquatic ecoregions, there are algae predominantly. And how it occurs? Basically, it occurs from the process of photosynthesis, which uses light as its source of energy. Also, it occurs in terms of chemosynthesis, which uses the oxidation or reduction of inorganic chemical compounds as a source of energy. And what kind of ecosystems are there? We have two types of ecosystems, natural ecosystems and man-made ecosystems. In the natural ecosystems, you have a terrestrial ecosystems and aquatic ecosystems. Terrestrial ecosystems are forests, grasslands, and deserts. In the aquatic ecosystem, you have two types, freshwater ecosystems and marine ecosystems. Freshwater, either you have a running, like you have a river, standing, you have a like a lake. So these are the kind of ecosystems that we will talk about. Okay, so now what is the meaning of net primary productivity or gross primary productivity? Because we have understood the productivity, rate of generation of biomass. We understood the primary productivity, rate of generation of biomass by the plants or by autotrophs. So what is the meaning of gross primary productivity or net primary productivity? So gross primary productivity is the amount of chemical energy as a biomass that primary producer create in a given length of time. It means in 1 year, how much this is getting generated. So how many grams or how many kilograms. What happens to this? Once it generates, some will be used for cellular respiration. So once it is used for cellular respiration, so there will be some kind of a deduction from the gross primary productivity. So gross primary productivity minus respiration by the plants is known as net primary productivity. And this net primary production is the rate at which all the plants in an ecosystem produce net useful chemical energy. It means it is equal to the difference between the rate at which plants in an ecosystem produce chemical energy and the rate at which they use the sum of this energy during the respiration. So net primary productivity is nothing but gross primary productivity minus respiration. Okay, once this is clear, I'll come to the ecosystem water use efficiency, because this NPP is nothing but the GPP minus respiration. There is another very good term called ecosystem water use efficiency. What we have done, we have used very simple mathematical formula to compute this ecosystem water use efficiency. What it does, it tried to couple two models. What are these two models or two cycles? Carbon cycle as well as water cycle. So carbon cycle, net primary productivity will come from carbon cycle and evapotranspiration will come from the water cycle. So what it does, basically it tries to quantify, it tries to measure how much water an ecosystem uses related to biomass generated. Biomass is nothing but the primary productivity, you are generating some kind of a biomass. For that, how much water I am taking from the ecosystem. It means ecosystem water use efficiency is nothing but a function of productivity and evapotranspiration. So the simple formula we have used, mathematical formula, ecosystem water use efficiency equal to net primary productivity divided by evapotranspiration. And what it does, ecosystem water use efficiency is maintaining the levels or it is increasing up during the drought year, during the deficiency of the rainfall. It means this is more resilient. Otherwise, we will say it is less resilient. How I can do the resiliency analysis? What we will do, we will compute the water use efficiency, ecosystem water use efficiency for every year. And we will find out the driest year based on the annual precipitation data. Once we will do that, we will find out the dry years, and the dry years, how much is my water use efficiency divided by mean water use efficiency. And based on that, we will define a index, some kind of index, which will help me to identify the ecosystem resilience analysis. That I will say RD. RD is nothing but water use efficiency in the driest year divided by mean water use efficiency. So water use efficiency in the dry year or in the driest year, and then the mean water use efficiency, if I will take that ratio, that will give me some kind of a indicator. It can be maximum 1. So if it is greater than 1 or 1, it will be resilient. It is from 0.9 to 1, I will say slightly non-resilient. If it's a 0.8 to 0.9, I'll say moderately non-resilient. If it's less than 0.8, I'll say severely non-resilient. So these kind of things I'll give some kind of an indication of various resilience class of water use efficiency, which is nothing but NPP divided by ET. So here's a full picture of whatever we have discussed till now. Ecosystem resilience. So what is the ecosystem resilience? There is a parameter for ecosystem resilience is nothing but ecosystem water use efficiency. Ecosystem water use efficiency indicates coupling of carbon and water vapor flux exchange between atmosphere and ecosystems. It means it is trying to couple carbon cycle as well as water cycle. Or I can say it will quantify how much water an ecosystem is gaining relative to the carbon gained. And this WUE is computed net primary productivity divided by evapotranspiration. So you have a Moody's data product that is available on NASA web page, net primary production and evapotranspiration. I'll get ecosystem water use efficiency with this formula. And your precipitation data of IMD, and then you will get SPI, and then you have hydroclimatic disturbances. In this present case, hydroclimatic disturbance is nothing but drought condition. Once we have these two steps, we will do ecosystem resilience analysis. How we will do the ecosystem resilience analysis? Or how will I label a system that this ecosystem is resilient? I'll say if an ecosystem is resilient, if it absorbs the disturbances and it sustains productivity by increasing or maintaining its water use efficiency under water limited conditions, which is induced by lesser annual precipitation. So it is for the drought conditions. Whereas a non-resilient ecosystem is not able to sustain the productivity under such conditions. So I have an ecosystem with me. If the system is producing its productivity, either increasing or at least maintaining under water limiting conditions, then I will say this system is resilient. If it is decreasing its efficiency, if it is not able to sustain its productivity, then I will say it's non-resilient system. That is the whole nutshell of this ecosystem resilience analysis. Once we have this kind of stuff in our mind, and this is only two formulas: ecosystem water use efficiency, nothing but NPP, net primary productivity divided by evapotranspiration, or water use efficiency in the driest year divided by mean water use efficiency, that's RD, index of resilience. So based on this, we will try to understand what kind of distributions are there of NPP and ET. Okay, this is the India map where you will find mean annual Modi's NPP data from 2000 to 2014. And this NPP data is highest for northeastern part of India as well as Western Ghats. And then you will find the Indo-Gangetic Plains has some kind of a moderate NPP ranging between 500 to 1500 grams of carbon. And the arid regions of Rajasthan, Gujarat, part of Madhya Pradesh, part of Maharashtra, they have least NPP. It means net primary productivity. What about the evapotranspiration? Evapotranspiration is highest in terms of Western Ghat as well as northeastern part of India, because these both the regions are the forest dominated and they have a higher ET, more than 1000 mm per year, and they have very less interannual variations, coefficient of variations of the 30%. So now what we have done, you have a NPP data, you have a ET data. NPP divided by ET, nothing but this will give me the water use efficiency, mean annual ecosystem water use efficiency. So what we have found out that lower Himalayan regions of north and northeast has higher water use efficiency due to higher NPP. If you remember from the previous slide, we have a NPP was higher also for Western Ghats, but because ET was also highest, so this ratio X upon Y will become lower, and we are getting only the lower Himalayan regions has higher water use efficiency. You can see it here, Western Ghat has low water use efficiency despite having high NPP. Also, interannual variability in terms of CB is in the water use efficiency is closely related to the CB in NPP, which indicate that water use efficiency in India is more controlled by NPP than ET. Okay, now I got a picture of how to compute NPP and ET for various regions. So this picture is very important. This slide is very important. This will give me the clear pictures. Where is the water use efficiency or ecosystem water use efficiency across the India? The first one you all know, this is Indus river basins. 2A is the Ganga river basins. 2B is the Brahmaputra river basins. 2C is the Barak river basins. Then you have a Godavari, Mahanadi, Narmada, Kaveri, all kind of river basins in the peninsular part of India. So in the right hand side of the figure, you will find water use efficiency, mean water use efficiency, standard deviations of mean water use efficiency, and then you have a MAP, mean annual precipitations. So what is more interesting, if you see this map, blue line, this is following continuously mean water use efficiency. Okay, except basin ID number 14. This basin ID number 14, if you see, the mean water use efficiency is around 0.5 grams of carbon, and then mean annual precipitation is 2000, more than 2500. So why it is so? So basin ID number 14 is which one? Basin ID number 14 is the Western Ghat, if you remember. This is the basin ID number 14. In basin ID number 14, you have a higher NPP and higher ET. Once you have higher NPP and higher ET, NPP divided by ET, this whole ratio will become lower. That's why you are getting the lesser water use efficiency. Okay, and higher the mean annual precipitation. Another important aspect that I would like to bring your notice is if you see the standard deviations of mean water use efficiency, this is highest for first river basin. First is Indus River Basin. Why it is highest for mean for Indus River Basin? Because a topography of Indus River Basin is such that you have glacier and snow dominated area here on the upper parts, then you have a plain area here, and then you have a desert part in western part of Rajasthan, and then this part. So this got a multifaceted geography of river basin number one, that's Indus River Basin. That's why it got different higher standard deviations of ecosystem water use efficiency. Okay, and highest water use efficiency is for 2B, and 2B is nothing but Brahmaputra River Basin, because in the Brahmaputra River Basin, it has large forest covers. It has large forest covers. So it has a large forest cover. It means evergreen, broadleaf forest, and mixed forest. They cover almost 24% and 22% of area of the Brahmaputra River Basin, which is around 50% of total basin area is being covered by evergreen, broadleaf forest, and mixed forest. That's why it has got higher kind of water use efficiency. Another is the Barak River Basin. That's 2C. This also have a large forest area of around more than 60.81% of the basin area. That's why this is higher water use efficiency. So I hope with these examples, this graph it's clear to all of us that mean water use efficiency is higher for 2B and 2C, followed by basin number 1 and 2A, while mean annual precipitation is highest for 2B, 2C, and river basin number 14. And standard deviation is highest for river basin number 1 of Indus River Basin, and the reasons for this is known to us now. Another stuff is Mahi River Basin. In Mahi River Basin, if you see, this got least water use efficiency because it has almost nil forest cover area. It has only around 80% of area is cropland. So that's why it was least water use efficiency of Mahi River Basin, basin ID number 10. So you have a highest water use efficiency basin, you have a lesser water use efficiency of ecosystem water use efficiency basins. So Mahi River Basin is the least water use efficiency basins. Then what we have done, you have seen the India's map with respect to river basins. That's 1, 2, 2A, 2B, 2, 20. Now what we have done, we have divided them into different kind of land cover types. Land cover types means you have evergreen needle-leaf forest, evergreen broadleaf forest, deciduous needle-leaf forest, deciduous broadleaf forest, mixed forest, greenland, cropland, and savannas or cropland natural vegetation mosaic. So if you see all these wetland types or grassland types, you will find that forest class has higher water use efficiency compared to the vegetation types. Vegetation has lower water use efficiency while we compare with terms of evergreen needle forest, evergreen broadleaf forests. Okay, so once we have understood the river basin types, land use cover type, we have done another kind of classification based on climate classifications, open Geiger climate classifications. I hope you all have seen this map of India where we have a different kind of climate classifications, AM, AS, AW, BSH, BWH, and then we have a CSA, CWA, CWB, and ET. So these are the climate classifications we have across the India. And then we have computed the water use efficiency for each of these climate types. And once we have computed for each of these climate types, what are our observations? What are our findings? Our finding says that temperate climate, CWA, CWB, they have highest water use efficiency of this region. If you remember, in the river basin also, Brahmaputra and Barak, they got higher water use efficiency because of the forest cover, and the forest also we have seen this has higher water use efficiency. So Copenhagen climate classification also says this got higher water use efficiency of temperate climate CS, CWA, CWB. Another I can say, if you remember this arid climate, BWH and BSH, BWH and BSH, they have least water use efficiency. So temperate climate have higher water use efficiency, CWA and CWB. Arid climate, BWH and BSH, they have a least water use efficiency. Once we have done all three kind of analysis, river basin type, land use and land cover type, and then climate type. Now let us understand which basins are resilient, which basins are not resilient. So here these are the 22 river basins. If you see 1 to 20, because we have 2B and 2C, so they are total 22 in the river basins. We have computed the mean water use efficiency for all these river basins. What is the formula for that? NPP divided by ET for each of the grade of 1 kilometer by 1 kilometer. So we got the mean water use efficiency of each of these river basins. Then, as per our methodology, we need to find the driest year. It means the year in which the lesser precipitation is there based on SPI. So this, based on this SPI, we find out that this is the driest year in that region or in that river basin. And how much is the precipitation in that region? That is mentioned here. Okay, and water use efficiency, how much is the water use efficiency in that driest year? It means, let us say for one, Indus River Basin, the driest year was 2002 and the rainfall was in 466 mm. In that year, the dry efficiency was ecosystem water use efficiency was 1.055. And what is the formula for resiliency index? Water use efficiency in the driest year divided by mean water use efficiency. Water use efficiency in the driest year for river basin number 1, that is Indus River Basin, is 1.055 divided by mean water use efficiency 0.802. So this is coming 1.315. And if it is greater than 1, I'll say true. It means it is resilient. So similar things I can do for all these river basins. 2A, that is Ganga River Basin. Mean water use efficiency in this river basin is 0.729. Driest year was based on these calculations of 812 and minus 0.2 minus 2.09. It's 2009. And water use efficiency in the driest year is 0.670, and RD is nothing but 0.670 divided by 0.729, that is coming around 0.920. It means this is less than 1, so I'll say false. It means this river basin is not resilient. Okay, so similar kind of stuff has been done for all 22 river basins. You can see it here on this slide. And out of these 22 river basins, how many river basins are resilient? It means how many river basins are saying it's true. So you can see number 1, number 2B, number 9, number 18, and number 20. So 18, 20, number 9, and 1 and 2B. So 6 river basins out of 22 river basins are saying they are resilient. Rest of them are saying they are non-resilient. Now this is the picture. So this slide is very important in terms of, this will give you the feeling which of these river systems, ecosystem river basins at different scales. So you can see this part of India is resilient, this part of India is resilient, green. 2A is slightly non-resilient, 4 and 8, they are moderately non-resilient, and all these stuffs, red, they are severely non-resilient. So first is Indus River Basin, Ganga River Basin, Brahmaputra, Bara, Godavari, Krishna, Kaveri, Suvarnrekha, Brahmani and Baitarni, Mahanadi, Pennar, Mahi Basin, Sabarmati, Naranda, Tapi, best flowing rivers of south of the Tapi Basin, east flowing river between Mahanadi and Godavari Basin, east flowing river between Godavari and Krishna, east flowing river between Krishna and Pennar, east flowing river between Pennar and Kaveri, east flowing rivers south of Kaveri Basin, and west flowing rivers of Kutch and Saurashtra, including Luni Basin. So, what is the conclusion? It says that two-thirds of the country is found non-resilient to the hydroclimatic disturbances. Almost two-thirds of the country. And part of the central India, basin ID number 3, that is Godavari Basin, basin ID number 6 and 7, which is Suvarnarekha and Brahmani and Baitarni, basin ID number 10, 12 and 13, 10 is the Mahi Basin, Narmada Basin and Tapi Basin. So, Godavari, Narmada, Tapi, Mahi, Suvarnrekha, Brahmani and Baitarni. These 6 river basins are found severely non-resilient. In general, I can say that two-thirds of the country is found non-resilient. Okay, so once we have understood the idea of river basins non-resiliency, now let us move again to the land cover type. So we have a different kind of land covers: evergreen needle-leaf forest, evergreen broadleaf forest, deciduous broadleaf forest, mixed forest, grassland, cropland, natural vegetation mosaic. Mean water use efficiency, you can see it here. Then you need to find out the driest year. How much is the precipitation in the driest year? Water use efficiency in the driest year. And we need to compute the RD, water use efficiency in the driest year divided by mean water use efficiency. And if it is greater than 1, I'll say true, otherwise I'll say false. So what it says, these only two are true, means only evergreen forest, evergreen needle-leaf forest, evergreen broadleaf forest, they are found resilient. Deciduous broadleaf forest, which had at least water use efficiency among the forest covers, are least resilience. So deciduous broadleaf forest are less resilient. So you'll find the few things here: evergreen needle leaf, evergreen broadleaf, all kind of things. You can find their water use efficiency here. Okay, DVF has a significant lower W compared to other forest types. Now the third and last one comes climate types. We have a different types of the climate that we have discussed just now: AM, AS, AW, BWH, BSS, CSA, CWB, CW, and ET. These are the different types of the percentage area they have across the India. So you'll find that AW and BSS, they have higher percentage of area compared to others. This is the mean water use efficiency. This is the driest year, and this is the precipitation in the driest year. Water use efficiency, how much in the driest year, and then we computed the RD, and then we need to find out whether they are resilient or not. So only 3: CSA, CWB, and ET, they are found resilient. Rest of the things are found non-resilient. So we have seen ecosystem resilience analysis with respect to river basins, with respect to land cover types, and with respect to climate type. So at various scales, river basin scales, land cover scales, and climate type scales, we have seen the ecosystem resilience. First, we have computed the NPP divided by ET, water use efficiency, then we computed the resilience. So coming to the whatever we've discussed just now, among all the river basins, Brahmaputra river basin has the largest forest covers of EVF and MF, which is around more than 24% and 21.82%, or they have around 40%, 50% of the area in terms of forest covers. Then you have a neighboring Barak and other river basins, basin ID number 2C, also has the forest covers and about 60.81% of the basin area, therefore higher mean water use efficiency. Then we have another basin ID number 10, Mahi River Basin, which says that it is almost less than 1% of the forest cover area. There's only the croplands are there. Brahmaputra River Basin has highest mean annual precipitation. There is the Mahi River Basin has very less mean annual precipitation, which shows the dependency of ecosystem water use efficiency on precipitation. But we have done another is that we have found a good uh, correlation between mean water use efficiency and MAP, and the basin ID number 18 has relatively higher water use efficiency in the southern parts because of presence of CNB. Moderate water use efficiency is found out because of the presence of the forest and the lower Himalayan region in the basin ID number 1, Indus River Basin. Now, there is another aspect we gave of economics, of trend analysis in terms of at national level. So if you see from 2000 to 2014, this is the graph of mean water use efficiency across the India, and this has an increasing trends with a magnitude of 0.0058 grams of carbon per meter square per mm per year. Increasing trends in water use efficiency in India is not consistent with the decreasing trends of globally. So that's one of the important stuff that we need to mention here. And if you see in 2009, there is sudden drop of ecosystem water use efficiency. And why this? There is a sharp decrease in water use efficiency in the year 2009, which can be attributed to the in the country's average net primary productivity 318 grams of carbon per meter square in 2009 compared to mean NPP of 365 over 2000 to 2015. And we should remember in 2009 there was a drought. We had a less precipitation, deficiency of the precipitation. So once there is a deficiency of the precipitation, ecosystem water use efficiency has been decreased in the 2009. So this is a kind of a trend analysis of national average ecosystem water use efficiency. Okay, so this is the trend analysis. If you see this, I have shown you as a single point across the India. This you will find in terms of various locations. So where it is decreasing, where decreasing, where increasing, and where significantly increasing. So you can find out across the India how it is happening in terms of ecosystem water use efficiency trends. And here you can find the same slope. If it's increasing, what rate? Of decreasing, what kind of rate? Between minus 0.202 to 0.071. Also, this also says here in terms of evergreen needle-leaf forest, evergreen broadleaf forest, and mixed forest, all kind of stuffs. So out of total vegetated area, around 81% area showed a significant increasing trends of ecosystem water use efficiency. Whereas around 55% of area shows significant, non-significant increasing trends in terms of ecosystem water use efficiency. The significant increasing trend was found for central India, you can see it here, and part of western, eastern, other part of India, and around 21% of the vegetated area had a non-significant decreasing trends, and only 2% has a significant decreasing trends. And the decreasing trends are mainly found in those Brahmaputra region which has higher WUE. Okay, so this is about ecosystem water use efficiency. Now we try to identify what are the climatic constraints for ecosystem water use efficiency or the primary production or the plant growth. Whether it is a precipitation, whether it is solar radiation, whether it is temperature, which one is contributing and which part of India it is contributing. So what we have found out in general, precipitation is the major climatic constraints over most parts of central India, western India, eastern India, and southern India. And if you see in terms of western Himalayan region, both precipitation and temperature together are the major climatic constraints. If I talk about the Western Ghats and the northeastern part of India, both have been dominated in terms of by solar radiations. So this picture will give me a little bit idea of what kind of climatic constraints are there of the plant growth in which part of the country. Last but I think not least, can we include this as a part of GDP or GSDP, gross state domestic products, because we need to understand what is the relation between NPP, net primary productivity, and gross state domestic product, GSDP. And this GSTC PP has been adopted as an indicator for industrial and infrastructure development, which is very important for urban environment. So here, this GSTP data we have obtained from Open Governmental Data Platform, this data.gov.in. What we have found out, every state in India has shown a consistent growth in GSDP in, between 2000 to 2014 and a consistent showing increasing trends. So this is the state level mean NPP. You can see Andhra Pradesh, Arunachal Pradesh, Assam, Bihar to West Bengal. Okay, northeastern states, Assam, Arunachal Pradesh, Manipur, Meghalaya, Mizoram, Nagaland, they have higher NPP because they have more kind of forest. Kerala also has a higher NPP because of presence of Western Ghats. Rajasthan has a lower NPP because of the Thar deserts and the arid climate. You have a less forest cover there. So these are the steps. So northeastern states you have seen, Kerala you have seen, and Rajasthan you have seen with respect to NPP and from 2000 to 2014. What we have done here, we try to identify the correlation between the NPP and gross state domestic product. What kind of relation is there? It's significant, it's non-significant. So most of the states, they are showing positive correlations between NPP and GSTP. What is the meaning of it? The meaning of it is very clear that NPP is not adversely affected by the development activities in the states. However, there was significant negative correlation for two northeastern states, Assam and Meghalaya, and two non-significant negative correlation for Nagaland as well as Uttarakhand. So you have significant, you have non-significant. So what we try to understand why this is happening, why there is a negative correlations. So what we got a report of FSI, Forest Survey of India of 2009, 2011 and 2015. So for the northeastern states, especially in terms of Assam, Meghalaya and Nagaland, what we have found out that encroachment in the forest land, biotic pressure and shifting cultivation, they are the main reasons behind the decrease in the forest cover in northeastern state. Whereas the diversion of the forest land for development activities are the main factor in Uttarakhand. So Uttarakhand, you have diverted the forest land, and northeastern parts, encroachment, biotic pressure and shifting. So this is the region of negative correlations. Okay, coming to the final summary. What are the final summary of this presentation? Higher ecosystem water use efficiency we have found out on the lower Himalayan parts of Indo-Gangetic Plain or in some parts of the northeastern Himalayan regions. Second is the precipitation we have found are the major climatic constraints. Most of the states, they show the positive correlation between NPP and GSTP. And out of 22 river basins, only 6 river basins, they were found resilient to hydroclimatic disturbances, leaving the rest behind the basin non-resilient. So almost 2/3 of the country was found non-resilient, and central India was found least resilient. And these are the few references we have used in the presentations. With this, thank you so much. If we have any questions, we can take now. We have almost, I think, 15 minutes.
Thank you, Manish sir.
Yeah.
Thank you very much for an excellent presentation. I'm too environment friendly person, so I was very much benefited with this presentation, and really the NPP that you've discussed. It is the first time I've heard this term, but definitely now in future, whenever I'll read more, I'll keep this term in my mind, and this will help me, and I believe the audience also, because being from the engineering background, generally we do not encounter these terms and these types of research. So now, audio, let me unmute the mic for audience, and audience can also ask their questions. Let me give them control. So now, audience have the control over their mic and video, so they may please uh, ask their question. Deliberations are open. Is anybody from the audience? Okay. Meanwhile, sir, one question from my end.
Yes, please.
Before anyone asks, generally it is said that a country must have 33% as its forest area. Currently in India, we have, I think, 23-24% of forest area. So, are we doing any progress in that area also? What is the future like? Can we achieve the target of 33% in any coming next 50, 100 years, or it will remain same as it is right now?
I think this is very, fundamental questions that government is also trying to increase the forest cover area, which is less than 25% as of now. But I think we have 1.4 billion population, and population is continuously increasing at least for next 2 decades. So once the population is increasing, people are shifting from rural to the urban areas, and these urban areas are become very critical, and they are changing whole kind of a demography and that environment. Once they change the environment, we need to cut the trees, we need to cut the forest, and how how we will get the another lands where we can put several trees, or we can have another kind of forest. So that's very challenging task, and basically we don't have an answer for that, that whether we will get the 33% in next 5 years or next 10 years or next 20 years. But at least all of government initiatives are there, many NGOs are working, they are putting uh, every year, month of July, you will see the plantations everywhere across the India. But when it will go to the 33%, we don't have any idea. So I think we all should work together, and we should get the 33% in the probably next 1 decades. That's the thing.
And even in our national determined goals also for the climate action, we have said that we are going to create a carbon sink of 2.5 gigaton, and so from that point of view, we need to increase our forest area.
Yes, that we have to increase our forest area. That's true.
Yes. Anyone else from the audience side? Okay, so Mohit Patel want to ask something. I just saw their mic blinking. Mohit sir, were you about to ask something? Okay, so no questions from the audience. So let us sum up the session. Uh, thank you very much, sir, for sharing your important time. I know it was very busy schedule, and very difficult for you to find the time for this session, but we are heartily thankful. And being an alumni of IIT Roorkee, me too. I have the privilege to share the same alma mater with you, and hopefully sometime we'll have a meeting with you, and we'll learn more from you. And further, I too request you that please extend your support in our future FDPs and the future conference or workshop that we need to organize. We hope that you will extend your support.
Okay, thank you so much. We'll meet again next time. Thank
Thank you,
you.
sir. Thank you very much, sir. It was a
Thank
great
you,
session.
sir. Thank you very much.
So we can have a small break before the next session, and then we'll again start.
But all will stay in tune with us. Okay. Do
Dr.
not leave
Shantanu
this
has.
meeting, है ना? Yes.
Okay. What is the update regarding the next session? It is going to start right now, or there is some time gap?
I will ask to Deepak sir.
Ma'am, please update so
Ah,
that we can update the audience also, and they can to
yes,
have
yes.
their break.
Yeah.
For the time being, we'll having a short break of 10 minutes. We'll join back.
The next session will start on the scheduled time, exact at 3:30 p.m. Yes, Dr. Rasil, you want to say something? Dr. Rasil Rahman? Dr. Rasil?
Dr. Ashir is not here.
No, no, Rasil. Dr. Rasil raised his hand. Dr. Deepak Swami is with us. He joined.
Yeah, yeah. Hello, Dr. Kiran.
Yes.
Hello, Kamlesh.
Hello,
Dr.
sir. Good afternoon.
Good afternoon.
So, just a minute. It's 3:30. I'm giving the just a minute. So, very good afternoon to all. We are going to start the 10th session of this Atal FDP, and the session is on AI in waste and water management by Dr. Deepak Swami. Dr. Deepak Swami obtained his undergraduate degree in civil engineering in 2007 from Engineering College, Kota, and his MTech Water Resource Development and Management in 2010, and PhD on groundwater flow and contamination in 2014 from IIT Roorkee. After completing his PhD, Dr. Swami joined IIT Mandi as a faculty member in 2015. Dr. Swami has demonstrated expertise in both experimental and numerical modeling of groundwater flow and contaminant transport through heterogeneous porous media. His research interests include parameter optimization, aquifer scale modeling, and source identification. Recently, he has expanded his focus to drought modeling using near surface soil moisture profiles. Dr. Swami has a substantial publication record with numerous research articles in peer reviewed journals, book chapters in the field of contaminant transport modeling. He currently holds the position of Associate Professor and Dean of Infrastructure at IIT Mandi, and additionally he has served as a visiting professor at the Department of Hydrogeology, KIT Germany, under TU9 BMBF collaboration from June 2016 to September 2016. He has an extensive teaching background, having imparted knowledge in a diverse range of subjects related to hydrology, hydraulics, and groundwater. His instrumental expertise encompasses courses such as hydraulics engineering, fluid mechanics, water resource management, wastewater engineering, groundwater flow, and contaminant transport modeling. Dr. Swami has received notable recognition for his contributions, including the G.M. Navathe Puraskar in Hydro 2019 by the Indian Society of Hydraulics for the best paper. So, heartily welcome to this FDP, sir. And Mike is over to you, sir. Dr. Swami.
Thank you. Yeah, thank you, Dr. Kiran.
Just a minute, Deepak sir. In addition, I would like to inform all the audience that Dr. Deepak Swami is also a poet. So he also writes poems and shairis, and so he has a diverse interest, multifaceted and multi-talented person. And this inspires others also to that not to restrict ourselves only to the technical domain, but there are many other aspects of a life, and that should also be explored. So that was a more addition information about Professor Dr. Deepak Swami that I would like to inform.
And Kamlesh, if you are mentioning that, I would also like to share that I also play badminton for IIT Mandi in inter-IIT tournaments.
Yes, yes, definitely. That's why I said you are multi-talented and a multifaceted person, sir.
Okay, so thank you. I'm really humbled to hear the polite words from Dr. Kiran and Kamlesh. Kamlesh is very dear to me. And Shankar is here. Shankar, can you please share the presentation?
May I know by which email ID Shankar has joined?
He's
Okay, let me on the control so that. Yes,
hmm,
Mr. Shankar, if you are there, can you please tell me the email ID so that I can make you the host? The name you have allowed.
yeah, he's not allowed to present.
Uh,
Probably,
I just want to know by which email ID, by which name you have joined, so that I can give you the host control. Shankar Yadav. Okay, I found it. I found it. Okay. Okay, I found it. Yes, sir. Shankar, now you are host and you can do share the screen. So is it Shankar? You are able to share the screen?
all right.
Is my screen visible to everyone?
Yes, Vinay, the screen is visible. Can you please turn on the presentation?
Yes.
Okay. So, thank you, Kamlesh and Dr. Kiran, for giving us an opportunity to share our experience, which is related to a global problem which we soon are going to face. The developed country has already started working in this direction. This is very interesting. So, before I start the formal presentation, I would like to give a background that what I'm going to present today. Basically, what happens that water is a basic need, we know, and with the ever-growing population, we cannot avoid the increased water consumption. In many part of the world, you must have heard the examples of Cape Town and other tourist destination where the water completely rain out. So the water is limited. We know this is a fact, and we have been taught also that the fresh water is only about 0.2% of the entire source. So considering that, and also the additional stresses given by the changing, ever-changing climate, the erratic pattern of the rainfall, and long, warm spells of the weather, they are forcing more water to evaporate from the Earth's surface, and then the water is being poured down at the locations where it is not needed. Considering all these things in scenarios like different countries are focusing more to use treated wastewater, how to recycle it efficiently, and how we can minimize the waste footprint from this treated wastewater and use it in a sustainable manner. So our talk is inclined to that. What we have analyzed is that different governments, including government of India, also make the sustainable goal to achieve at least 70 to 80% of the treated wastewater should be reused. However, the facts and the reality is far-fetched, considering that most of the cities do not have the wastewater treatment plant. So what they do with the waste, they generally simply store in the septic tank and take it to the existing treated wastewater unit where they treat it and discard it. Now, what it does do, we know that a treated wastewater treatment plant are generally designed to host a capacity to treat uh, uh, some uh, some million liter per day. But if you increase that efficiency, increase that capacity, then the efficiency of the wastewater treatment plant drastically goes down, and then it affects the effluent quality. Recently, 5 years ago, Government of India has also intended to change the norms of treated wastewater to be discarded onto the land or into the streams. So earlier, the limits were the BOD and COD limits were quite high. So BOD limit was 30, 30 ppm and COD limit was about 250 milligram per liter. But 5 years ago, government has made these strict norms that the BOD should not be more than 10 ppm and the COD should not be more than 50 ppm. So considering that fact that the government is really aware about the kind of treated wastewater they are discarding and kind of problem they are creating, the focus is to reuse the treated wastewater. When we are trying to use slides are not changing. I'm still on the title slide. So once the slide will change, you all get to know. Okay? Changing right now. So considering that there are several avenues where this treated wastewater is being focused to reuse. In 2019, government of Rajasthan made a plan to completely utilize the treated wastewater and achieve an efficiency in the treatment for about 70 to 90%. In 2019, there is a document about it. Where they are using it? They are using it in the food, horticulture, aquaculture, and in some part of the country, they are also trying to use it in the drinking water. Now, what is the problem? Since we know that the human being are susceptible to disease, we all consume medication, different order of the medication, the diseases are increasing. We all are depending on the multivitamins and antibiotics and several kind of things. And because of that, our wastewater treatment plant are not designed to remediate the kind of emerging contaminants with other than the organic and chemical contaminants which were there in the treated wastewater. So this leads to this interesting work which we are carrying out right now is the selected emerging contaminant in water, how they are occurring globally, what are the existing treatment technologies, what are the regulations available, and associated risks if we are going to reuse into the agriculture or aquaculture. So from that perspective, we have prepared these slides. So my student Vinay, he has published a very good research article recently in an impact factor of 12.5 in Journal of Hazardous Material. So he is going to present this case study that how did we carry out, how did we get to know all the details available related to the emerging contaminant and their global occurrence in the water. Vinay, can you please start sharing the knowledge?
Yes. Good evening to all. As discussed by sir, that we are all the governments and organization around the world is working in this direction of the wastewater reuse of wastewater and the reducing the water stress. But to reuse wastewater, we need to completely know what are the problems related to wastewater and how big these problems are in the present day. So what is happening is we all know that the human population is increasing daily, and with this increasing human population, the two biggest problem which are coming with it are the water scarcity and the generation and safe disposal of wastewater. So around 3.6 into 10 raised to the power 11 meter cube of wastewater is produced annually, and out of which 80% is discarded in the ecosystem without getting properly treated. So we all know this is a very big problem, that this wastewater is being discarded in the environment, not being treated. And you can see these articles related to this published in various websites and news headlines. So, with this water stress and wastewater related problem, the best solution which the research community found was the reuse of this wastewater. And we can see that the majority of this wastewater is being reused in the agriculture and related sectors. But what is this right, or what are the issues related to this wastewater or reuse of this wastewater? So,
Oh, Vinay, a small humble request.
yes,
Go a little slow. If we are going too
okay,
fast, and we need to capture that knowledge also what you are sharing.
okay,
So that's why a little slow,
okay, yeah,
so that we
fine.
can get sufficient time to understand and digest the
Okay,
knowledge.
okay. So, what are the issues with this wastewater? First is the chemicals present. Like the biggest problem is the recently identified emerging contaminants and organic pollutants like pesticides and all. And then second is the inefficient treatment of these emerging contaminants. The conventional treatment technologies which are currently available in the developing countries are not completely treating these emerging contaminants and these organic contaminants from the water. And then the third biggest problem is the lack of proper regulatory structure which can reduce the occurrence of these contaminants in the global water bodies. And finally, if these contaminants enter the water, then what risk they pose to human health. Then considering these four problems, we started our case study regarding the knowledge available about these in the direction of these four problems. So you can see many articles have been published related to these problems only, like EU. According to European Union, out of 1 lakh registered chemicals, almost 30 to 70% are in daily use. And second research suggests that 300 million ton of synthetic compounds, which include microplastics and PFAS and all, out of this 300 million ton of synthetic compounds are introduced to natural waterways through industrial products or industrial wastewater discharge. Then uh, Narvaez et al. In 2017 reported the inefficiency of the conventional treatment technologies uh, uh, in removing the recently identified pollutants. And what is happening is, among these emerging contaminants, pharmaceuticals are the most commonly used compound. And when these pharmaceuticals are introduced in water, and when the water containing pharmaceutical is being reused for agriculture related sectors, then there are chances of the uptake of these contaminants by the plants. And if the plants are edible, then it can enter to human food chain. Then you can find articles which suggest that what we know about these pharmaceuticals and personal care products and also the emerging contaminants is very less, and we need to get more research and more detailed study. And you can find news related to these problems from Hyderabad. Also we can see that Hyderabad's lake is getting antidepressants, painkillers, and cocaine in the trace of cocaine. Then is you then you can see that if a food is watered by wastewater, then what can happen. Another research you can find, crop irrigated with wastewater is a threat to human health, which is from Banaras Hindu University. So this problem is now globally accepted, that there is a problem with the reuse of wastewater or the problem with discharge of wastewater. So, what are the emerging contaminants? Emerging contaminants are contaminants which are recently identified or which are present in environment for a longer period but recently identified, or the contaminants which are in a environment but and can have a potential threat to environment, human or aquatic life. And the major classes of emerging contaminants include endocrine disrupting chemicals, pharmaceuticals, personal care products, pesticides. Pesticide is a contradictory category because some countries or organization include pesticide in emerging contaminants, some not. So then the uh, uh, PFAS, perfluorinated compounds, microplastics, and flame retardants. But emerging contaminants are not limited to these categories only. There are many more categories like surfactants and uh, other micropollutants are also there, surfactant, detergents, and etc. So it is a very broad category, but in our study we have selected only few of the most widely occurring categories of the emerging contaminants. So, what are the impacts these emerging contaminants can have on human health or aquatic environment when present in water? So, for humans, they can cause the chronic disease, or some contaminants like MTBE can cause cancer risks, and they can also suppress our immune system. And in aquatic life, there are traces that the emerging contaminants can alter the reproductive behaviors of the fishes, and the toxicity, they can be toxic to aquatic life, like microplastics when inhaled, when uptaken by or inhaled by the aquatic environment, in the aquatic environment, then they can be really toxic for life. Then when the compounds enter, then the solution to this is the treatment. So from the review, we found the treatment technologies around the world available for the removal of emerging contaminants from wastewater. So the treatment technologies are broadly classified in four categories. There are physical, chemical, biological, and hybrid. Then physical are adsorption, membrane technologies, and reverse osmosis, which we are very well aware of. Then in adsorption, there are studies which use natural materials like the way agriculture, like the sand, different sand, or coal absorbent and all. Then agriculture waste, majorly the waste from the rice husk or wheat waste, they are being used as a treatment membrane. They are being used as a filter membrane for removing the emerging contaminants. Then there are some synthetic modified absorbents which are being developed considering the chemical properties of the different emerging contaminants. Then we have membrane technology based on the size of pores in the membrane. These are microfiltration, ultrafiltration, and nanofiltration. Reverse osmosis, we all know. Then the chemical treatment technologies are chlorination, ozonation, Fenton process, photolysis, photophanton, and photocatalysis. Then similarly, the biological treatments, aerobic and anaerobic techniques, we all know. Then the degradation of emerging contaminants using bacteria. Then the application of nitrogen to reduce the the emerging contaminant concentration, and the application of microalgae on the wastewater. Then, but these three technologies are not completely efficient in removing the emerging contaminants. So the research community came up with the fourth solution, the hybrid technology. Hybrid technology is nothing but it is the combination of two or more technologies, that can be one physical or one chemical, or two biological technologies, one chemical, one biological, anything, but it is a combination of multiple treatment technologies. So these are advanced oxidation, membrane bioreactor, and constructed wetland. Constructed wetland technology is currently gaining a high popularity, uh, and it is also not very much efficient, but it is having a good efficiency in removing the emerging contaminants. Then these are the efficiencies of different treatment technologies in removing different classes of emerging contaminants. From the study, from the figure, it can be seen that the Fenton and photophanton process is removing almost all the emerging contaminants quite well. But in case of pesticides, the removal pesticides and EDCs, the removal efficiency is relatively decreasing. And the UV photocatalysis is having a good efficiency in removing the emerging contaminants. And but again, in case of EDCs, it is also relatively less efficient. Then in case of biological treatment technologies, you can see that in biological treatment technologies, biological activated carbon is having a good removal efficiency for majority of the contaminants, except the EDCs. And this impact of treatment technologies not removing EDCs will be seen in the when I will show the result of risk and occurrence. Then come the hybrid technologies. In the hybrid technologies, it was seen that the MBR technology is efficient in removing the lipid regulators, but for all other categories, it was relatively less efficient. And the ozonation is highly efficient, or the best technique in case of hybrid category for the contaminants we targeted. And then the second one is the constructed wetland based treatment technologies. Then comes the operational cost, that the cost, will it justify the treatment or not. So here you can see the comparison of the operational cost for different treatment technologies, and different type on what type of emerging contaminant it is being applied. What are the key findings from the this section about the treatment technologies? That apart from EDCs, UV photolysis and H2O2 and photofountain were the two most efficient chemical methods for removal of ECs. And then, although ozonation and UV photocatalysis shows a high removal of EDCs, but a relatively lower removal in case of NSAIDs, that is non-steroidal anti-inflammatory drugs, which includes this ibuprofen, diclofenac, and naproxen and all. Then UV photocatalysis was the underperforming in case of beta blockers and lipid regulator. In case of biological treatment, activated sludge was the most efficient technique. Activated and then biological activated carbon technique was more suitable treatment for ECs, considering high removal for all the classes of EDCs except all the classes of EDCs except the ECs except the EDCs. And as I already discussed, that MBR was the least efficient, and constructed wetland was second, and the most efficient technique was ozonation based treatment technology. Then after treatment, these occurrence maps are in the fresh surface water or groundwater bodies. So all these occurrence are after the treatment of wastewater, and you can see that the emerging contaminants are highly occurring almost throughout the globe. In each continent, the occurrence of emerging contaminant is showing a good, but which is not a good sign for us. So the first figure is showing the occurrence of non-steroidal drugs in the environment, aquatic environment, and then second is the antibiotics. Then the these three figures. The first one is showing the EDCs in the water matrices, then the psychiatric drugs, the drugs which are used to treat the mental problems. Then personal care products which are being used in our soap and the antiseptic and the beauty creams and all. So these products are also highly occurring in the water matrices. Then what we found when we studied this occurrence, the non-steroidal drugs diclofenac, ibuprofen, and naproxen was highly reported in the Asian country Pakistan, and carbamazepine was constantly detected in water, with highest persistent of the drug was detected in Ecuador. This carbamazepine is a psychiatric drug, and a high number of studies suggest that carbamazepine is also widely utilized in South America. And the highest concentration for EDCs was reported in Mexico, and the maximum concentration for antibiotics sulfamethoxazole. Sulfamethoxazole is an antibiotic, and this is reported in also Ecuador, and African countries show a frequent detection for this drug. Then highest concentration for personal care products is reported in Mexico. So from these findings, we can see that the occurrence of emerging contaminants is the occurrence of these emerging contaminants in not like that if EDCs are reported a maximum in Pakistan, then personal care products will also report high in Pakistan. So when changing the emerging contaminant, the occurrence will also change. So these are widely highly spreaded throughout the globe because of their broad class. So these are highly spreaded throughout this globe. Then what are the existing frameworks? Although the existing framework is not much strong considering the emerging contaminant, but two of the world's biggest environmental agencies, the US Environmental Protection Agency and the European Union, they have tried to publish some document regarding these emerging contaminants in water, but they have not given any regulatory guidelines. Instead, they have given a candidate list in case of US and watch list in case of European Union. This candidate list and watch list just listed the name of chemicals which you need to see or you need to take care, because these can be concerning for the environment. So they have only listed the names of the chemicals which can be concerning for the environment, but they have not given any guideline that for heavy metals or other arsenic and all, we have some concentration value that the value in water should be less than this or not more than this. So they have not given any such values. And in Europe, USA usually updates its candidate contaminant list. So the inclusion of emerging contaminants in a candidate list came in 2016 when they included flame retardants in their contaminant list in 2016. And then the latest candidate list was published, candidate contaminant list was published in 2022, which included the PFAS, which are fluorinated compounds in the contaminants with high priority. Like you have to monitor these contaminants in the water and wastewater. Then European Union, on the other hand, also published a watch list, which is also serving the same purpose, that you have to monitor the watch list contaminants in the water bodies. And the list of European Union, you can see in the table that the contaminants which European Union has listed as high priority contaminants and which are need to be watched in the water. But they are also not given any guideline value or limit for these contaminants. And you can see diclofenac, which I think almost everyone of us has have heard about. This diclofenac is also been included in this watch list. Then other common contaminant, estrone. Estrone is this hormone. So this hormone is also been included in the candidate list. Then after getting these details about the lack of guideline values and the occurrence and what are the concentrations available, we try to carry out the human health risk assessment. So it is not easy to carry out the human health risk for all the emerging contaminants. So we have selected 10 most highly occurring emerging contaminants from the category of antibiotics. We have selected diclofenac, ibuprofen, and naproxen, and then from the category of psychiatric drugs, we have selected carbamazepine. Then from antibiotics, we have selected sulfamethoxazole and ibuprofen. And from EDC, the endocrine disrupting chemicals, we have selected two hormones, is 17 beta estradiol, estrone, and one industrial contaminant, which is bisphenol A. So after selecting these 10 contaminants, we have carried out the human health risk assessment for these 10 contaminants. And what this slide explains the methodology which we adopted for this human health risk assessment. So the risk is being given in terms of risk quotients, which is calculated by getting the ratio of the concentration in the water body plus the calculated drinking water equivalent level. And this risk is calculated only in terms when considering the water being ingested by the humans. So for the human health risk assessment, only the surface water, groundwater, and drinking water are considered for this risk assessment. And in the risk quotient, we have divided the risk quotient in three categories. Risk quotient more than 1 has shown a high risk, where and risk quotient less than 0.2 has shown no appreciable risk, and the values ranging between 0.2 to 1 has shown that there is need for further detailed assessment to get a proper detail about the contaminants. and you can see the equations and their descriptions here. So after risk assessment, these figures show that how this risk quotient is spreaded for different contaminants in different category. The first figure is for infants, and you can see that for infants, BPA is showing the highest risk. Here, this red color of the area is showing potential risk. This yellow zone is showing detailed assessment required, and the green zone is showing the contaminants with no appreciable risk. So from the figure, you can see that in case of infants, the BPA is showing the highest risks, followed by estrone, and this estradiol is also showing some risk, and the ibuprofen is having the lowest risk. Ibuprofen and the erythromycin. Erythromycin is the another antibiotic we also consider. So this is showing these are showing almost no risk, and a similar pattern can be seen in this in case of children also, and in case of adults, you can see that in case of adults also BPA is showing the highest risk, but the plot has a little bit changed in case of adults. That you can see in case of triclosan, the area in case of you can see in case of ibuprofen, this in case of children, the ibuprofen risk is touching this yellow part, but when we consider adults, it is going down. Then these are the risk plots, that which location in the world is showing a risk about which contaminants. So these antibiotics, as we see earlier, that this diclofenac, ibuprofen are not showing risk. So you can see that there is not much risk regarding the antibiotics and carbamazepine. But when we consider EDCs, you can see the risk due to EDCs is widespread throughout the globe. You can see that this is Asia, our country, this Asia, India, Pakistan is also showing risk due to EDCs, and that too due to multiple contaminants like due to estrone, and and you can see due to this estradiol and BPA, majorly due to estrone and BPA. This Asia is showing a high risk. Then in Europe is also showing high risk due to BPA, which can be clear from the figure. Then Africa is showing high risk due to uh, estradiol and BPA, and same is the situation for the American continents. So you can see that say EDCs, which I discussed earlier, that EDCs are not properly treated by majority of the treatment technologies, which usually treated all the emerging contaminants with a good efficiency. So the results are evident with this figure also, that EDCs are posing the highest risk among all the contaminants. Then lastly, we have considered the non-steroidal drugs, and you can see this non-steroidal drugs, and it is not like that they are not showing risk, but they are more under the category of detailed assessment. So we have to more explore about these non-steroidal drugs, diclofenac, ibuprofen, and all, and that I am sure that these drugs are also well utilized in India. So there are chances that these drugs might be present in Indian water also. Now, what we found from this risk assessment, that EDC poses the highest risk with estrone and BPA having highest locations with the potential risk, and diclofenac, 710 beta estradiol, and sulfamethoxazole exhibit a similar trend where majority of the locations fell under no appreciable risk category, and some data indicated need for further assessment accompanied by few points with potential risk category, and trend for ibuprofen and ciprofloxacin, carbamazepine, triclosan, and erythromycin indicated a minimal risk. So this is the complete study which we have carried out. First, we studied about the emerging contaminants in water. Then we have studied the what are the treatment technologies available for the wastewater treatment. Then we have studied the guidelines available and the occurrence of these emerging contaminants in global water matrices, include majorly the freshwater matrices, which include the drinking water, the river surface water, and the groundwater. And then considering the concentration detected in these water matrices, we started the human health risk assessment, and it is evident from the study that these contaminants can pose a high risk to the human health. And if considering the po- population and pollution trend, uh, it can be seen that this concentration will rise with time if not mitigated. If not mitigated on time, then this concentration will definitely rise in the in the coming time. So we have to see that what we can do about these emerging contaminants in water before reusing this wastewater or before discharging the wastewater in the freshwater environment. Then now,
Vinay, just a second.
yes, sir.
Yeah. So thank you for this presentation. So while we investigated that the emerging contaminants are inevitable and it has become a daily routine to discard this emerging contaminant into the wastewater treatment plant, we are bound to reuse this treated wastewater. So what we are doing about it? So not only we identified that these wastewater are posing some serious problem while discarding, but we also wanted to identify the possible solutions and possible risks associated with reusing of the treated wastewater containing emerging contaminant. So what we are doing with the Quad Country Association, we are trying to solve this problem while taking experts, professors from Canada, Germany, Australia, and USA, where Iowa State University, McGill University, and Leibniz University, Hanover, from India, IIT Mandi. We all are trying to solve this problem, that how it is going to affect the food chain, overall food chain. And we are trying to utilize the latest tool like AI and ML, that how we can best utilize the treated wastewater into the irrigation, while with the conflicting interest of it should not be taken up by the plant from the irrigated water. What do I mean by that? So Vinay has presented a very interesting figure here. We can see that the tomatoes are grown, and what are the physical processes going on while tomatoes are growing. We are showing it, and these processes are particularly related to the complete physical cycle of the plant when it takes up the water from the subsurface, shallow subsurface water. So let's say if this water contains certain kind of chemicals, so what this chemical will do? First of all, the general processes are that there will be evaporation, infiltration, and evapotranspiration by the plant. But apart from that, these contaminants will also go under degradation. They will accumulate in the roots, which you can see through this black and red molecules at the root scale. There will be sorption processes in the soil by which this contaminant will get attached to the soil surface. And while they are attached to the soil surface, if let's say we are supplying contaminated water again, which is coming from the domestic or industrial wastewater treatment plant, which has the some concentration, inherent concentration of these contaminants, this sorption will further aggravate. They will accumulate. Now, root generally extract water from the soil at uh, certain pressure, certain suction head. So that suction head generally varies between 33 kPa to 15 bar. So if the soil is well saturated, we would say that the soil is at the field capacity, and it will extract the water with higher efficiency. And when the soil moisture drops, we say that the plants are drying up and they are going under wilting. And that time also we supply water. What plant experiences when the soil is very dry, it is thirsty for the water, it try to extract the water from the roots with the increased suction rate. So when it is trying to draw the water at increased suction rate, and other are attached to the soil surface, which are not easily separated, they also get sucked with the root, and then they try to come up in the root first. Then there are certain translocations and transpiration processes which plants do to make food, to make fruit, to make leaves. Then these contaminants through the stem, they go to leaves, and then from leaves they go to fruit, and then it start accumulating into the different parts of the plant. Although during this process, volatilization and metabolization also takes place, but there are very complex compounds when we talk about the emerging organic contaminant. They are formulated within the plant by its own mechanism. So this science is still evolving and it is completely unknown. Now, what we are trying to achieve here, the processes which I just described may sound very complex to you, but there are established mathematical models to particularly take out the parameters to understand that what's going on, how much contaminant will go to the fruit, how much contaminant will go to the leaves and stems and etc. And through those process-based models, we can actually predict that how much water, how much contaminated water can be supplied to one particular plant, and in what concentration it will be available in the stem, leaves, fruits, and roots. So this complete process is known as dynamic plant uptake model. I would like to give a small example here that in today's fast changing world, we all are aware that we should go for the organic food. And we are particularly paying high price to get the organic food at our kitchen. And while consuming it, we become very happy that now we are consuming the healthy food. I would like to give an example, which was experiment which was conducted in China for almost 15 years. They did not supply any kind of synthetic fertilizer to an agriculture field where they were growing the peanuts. So while irrigating the peanuts, they did not use any kind of treated wastewater. They were simply using the fresh water coming from the river, and they supplied only organic fertilizers. So in India, there are strict laws that if we want to convert our farming into organic farming, we have to at least go for 4 to 5 years for organic fertilizer. Then we have to test the soil for kind of contaminant it has. Similarly, the Chinese also, they do the same stuff, and then they also evaluated, yes, we are not supplying any kind of contaminants or synthetic fertilizer to the land. But interestingly, they were supplying the cow dung coming from one particular animal farm. There, the cow were fed the organic fodder. But while feeding this cow the organic fodder or that was irrigated with the treated wastewater, so it has some traces of antibiotics. Also, the cows, to remain healthy and to prevent any kind of disease, they were also fed some kind of antibiotics in their dung, in their waste product, in urine. These traces of antibiotic were coming up. Those traces of antibiotics are not generally degradable. They do not die themselves. They do not create any kind of chemical composition by themselves. They were coming up into that experiment. And when this organic fertilizer coming up from these cows were supplied to these experimental site for 15 years, they were continuously appearing. After 4 or 5 years, they started appearing into the peanut fruit and into the peanut skins. So the scientists were surprised that even after taking so much caution, how these traces of antibiotic, particularly the carbamazepine and other compounds, are appearing into the peanut skin and peanut shells. They try to trace back the problem that how it has happened. So they started analyzing the soil health again. So generally, if you go for the soil health card at Government of India, you would find that we have NPK, then pH values and some kind of heavy metals and these kind of things. But they are not aware to trace for the emerging contaminant like the carbamazepine, the antibiotics, and other kind of stuff. We don't have that facility right now. And then the Chinese started evaluating all these things and they identified, yes, the traces of these kind of contaminants were heavily available in the root zone of the plant and the plants were sucking up these kind of antibiotics. So thereby they started looking things more carefully. And what we found out after so much of the literature review that while we are doing the plant uptake modeling, the translocation, volatilization, the particle deposition, and in order to ensure the plant growth and also the metabolization of the plant, we need to supply certain amount of nutrients. Not all the nutrients are taken up by the plant. So it is always important that we identify a concentration which is there in the root zone, which plant will uptake, and they will not uptake the emerging contaminant. For that, we require the latest tool such as artificial intelligence, clubbed together, assembled together with the deep learning, machine learning, and these kind of process-based models. So this is what we have started. You can move on to the next slide now. Yeah. So here you can see that one of the experiment which Vinay had carried out into the lab, that we were training our mathematical model for one particular kind of contaminant, which is carbamazepine, which is neutral in nature. So it does not have any positive or negatively charged particles in it. So we created a standard carbamazepine solution into the lab by dissolving certain amount of carbamazepine in nanogram per liter into DI water. And then we started irrigating the green chili and tomato plant. Although because of very harsh weather at Himachal Pradesh, our plant did not grow fully, but we were successful in training the model. So while after supplying this uh, carbamazepine water to the tomato and chilies, we were also monitoring the growth of the plant. And we supplied the other normal fertilizer, NPK fertilizers and all. And we were monitoring constantly the growth of the plant. So then we realized that how do we test it, that what is the concentration of carbamazepine chemicals which we had supplied into the root, stem, leaves, and fruit. So for that, we have to sacrifice the plant, and we have to destroy the plant, take out its roots, then stem, leaves, and fruit, and analyze it separately. So from that, we try to validate our model. Now I request Vinay to elaborate on the process, that how we sacrifice the plant and how did we test for the emerging contaminant concentration in the plant compartment.
Yes, sir. I request I need to change the presentation. For that, please
Okay,
allow me to
please go
change
ahead.
the presentation.
Yeah, please go ahead. Please go ahead. No problem.
Yes.
So meanwhile, we are changing the presentation. So while we supplied this concentration to the plant, we were interested in knowing that there are instances such as the peri-urban areas of Delhi and NCR regions where people are supplying treated wastewater for irrigating the ready-to-eat vegetables, particularly. And we have a notion of consuming these vegetables directly, such as capsicum, cucumber, tomatoes, and their raw consumption is increasing day by day, considering that the people are becoming more health conscious for having salads on their plates and all. And when these ready-to-eat vegetables are directly grown from the treated wastewater, it becomes completely it becomes completely contaminated sometime if the farmers are not well informed about this, that how much irrigated water they have to supply. how much treated wastewater they have to use, how much fresh water they need to mix up with the treated wastewater. And if they are not taking these kind of decisions, then these emerging contaminants are appearing at our food table in forms of salad and ready-to-eat vegetable also. Okay, Vinay, are you able to find the slides?
I'm having
Uh,
some network issues, so I changed the connection. Just give me 1 more minute.
Okay, okay, no issue, Vinay.
Yeah.
While Vinay is connecting, just I would like to inform that I am too pure vegetarian and love to have salads on the table.
Hmm.
And recently, I just saw a video on YouTube,
Hmm.
and I don't know how it's correct the information is, but he said that the vegetarians, they are facing more number of cancer cases as compared to the non-vegetarians, because vegetarians consume vegetables and this too much, and because of excessive consumption of vegetables and salads, so these cases of cancers are also increasing in vegetarian people.
Not
So
only this,
how
Kamlesh.
do you know this?
Yeah, yeah. Not only this, I'll tell you one more interesting study which one of my MTech biotech student carried out. So we were investigating with carbamazepine and some other chemical. I'm forgetting its name because I've been dealing with so much chemical. So there is one chemical which is generally fed to the farm. Uh, uh, this it's slipping out of my mind. Farm animals. So those farm animals, and they are fed these kind of chemical to remain healthy. And when this is coming on to the cooked meat, it is also not safe for consumption. That if the farm animals are being fed the antibiotics, it may appear also in different parts of their body part. And there are studies which clearly says that these kind of emerging contaminants are generally, even after cooking, they do not go away easily. So, be it the case of vegetarian, be it the case of non-vegetarian, the emerging contaminants are part of our life. In fact, the non-stick cookwares which we generally use, they contain a very elite class of chemical which is known as PFAS and PFOS. So they come from the non-stick coating. So USA and Australia, they all are doing extensive research in PFAS and PFOS, that whether it is safe to use non-stick cookware or not. Our personal care products, they contains very different kind of chemicals which are also appearing into the treated wastewater. So yeah, poultry
True,
farm. So
true.
in the poultry farm, there are certain kind of hormones which are fed to
Yeah,
the
oxytocin.
poultry
Oxytocin is
chicken.
generally given to the young, to the cows which are in the which have recently given birth to the babies. So
Uh,
because oxytocin hormone, it flexes the muscles of the cows, and the cows unable to hold the milk. And here also we
mhm,
try to our NGO, we try to educate and aware all the people who are milking the cows not to
mhm,
give oxytocin injection, because it is very cheap in the market, and but that oxytocin is very harmful to the babies. So
mhm,
here people are
mhm,
using that in large scale oxytocin injection, and that is very harmful
mhm,
for the pregnant ladies as well as the babies.
mhm, mhm.
So we are
So
trying to aware
yeah,
people.
yeah. That's one thing. There are also these eggs which are coming from the farm. They contains like ampicillin and this kind of chemicals. There is South Indian movie on this, in which Siddharth is an actor. So he is an health inspector. He keeps on tracing that how these ampicillins and all these antibiotic residues are coming up, because this causes a female girl child to attain the menstrual cycle earlier than their age. So these
Right,
are the very adverse effect which are
right, right.
coming up from these antibiotics. All right, so let's see at the presentation which Vinay has shared. Yeah, Vinay, you can continue now.
Yeah. So this dynamic plant uptake. Dynamic plant uptake is like when a chemical is uptaken by the plant, how it is translocated in the translocated and transformed in within the plant. This is called the dynamic plant uptake. So dynamic plant uptake majorly depends on five plant properties, which are the water content, the lipid content, the initial mass of these each plant compartment, then the maximum mass of the plant compartment, and the growth rate of each compartment, and then the specific area for each compartment, and finally the density of each compartment. So to carry out our study, when if we when we grow these plants under contaminated or spiked water, then we have to estimate all these parameters, the water content of roots, leaves, stems and fruits, then same for the lipid contents of all the four, then initial mass that we can calculate by interpolating or extrapolating the plot. Then if we get the values of mass for time duration, then we have to plot that, and we have to see the trend that how this mass has changed, and then we can calculate the initial mass, then the maximum mass we can get in the mass of the compartment during the time of harvest, then the growth rate we can easily calculate using the growth biomass of the plant compartment within two successive time intervals. Like if we have taken first observation at 13th day and the second at 21st day, then we will check the biomass in case of each compartment, in case of each day time duration, and then we can calculate the growth rate with respect to biomass. Then the specific area we can calculate using the area per unit weight, that is the specific area, so we can calculate that easily. And then the density, which can be calculated using the float and sink method. So after calculating all these parameters, we move forward, uh, and then comes the properties of the chemical. So uh, there are two main properties, three actually. The log KOW, which is the octanol water partition coefficient. This basically describes the degradation rate of any compound in water. When in water, what how it will degrade, what will be the rate of degradation. This parameter basically describes that. Then KAW, which is air water partition coefficient. As we all know that are these chemicals can be volatile and can be neutral. So in case of neutral compound, KOW plays a major role, because we all know that this chemical will not convert in gas. But when the compound is volatile like benzene, in that case, this KAW plays a high role in this translocation and distribution of the contaminant within the plant, because when it will be volatile and when it will convert in gas, then uh, the contaminant will be uptaken through roots, but as well as through the stomatal openings in the leaves. So and then this KAW
Uh,
air water partition.
Vinay,
Yes.
I would like to request you to brief up at the earliest, because the other guest would also be waiting. It's 4:30 and the time for
Okay,
the
Kamlesh. Okay,
lesson.
Kamlesh.
Yeah, sure.
So let's wrap it up. So what this matrices actually shows the assemblance of the parameters and how they are appearing into the plant, and what processes they are following. So basically, we need not to go into the detail of solution of this
Okay,
partial differential equation, Vinay. We can simply conclude this. So
okay,
we
sir.
can come to the last slide.
Okay, sir. So this is our
Yes, yes.
strategy, which will that how we will use AI in our experiments, or our plan, how we are going to use AI. So first, when we will carry when we carry the experiments, then we have the data about this translocation of the contaminants in different plants, and after that we will run a hydrous model for different scenarios, and we this hydrous model, we will validate our model using the experimental data we have, and using this model we generate different scenarios for the contaminant plant uptake, and with this data we will uh, generate different realizations, and then train our model and test the machine learning algorithm for the generated data, and then uh, we can couple the machine learning model with the optimization algorithm to estimate the optimum dose of treated wastewater. But optimum dose, like in our experiments, what we are doing, we are using the treated wastewater with some dilution factor. So using this machine learning algorithm, we are looking to identify that what is the best dilution factor which can reduce the stress on the fresh water, but simultaneously which have the least risk considering the plant uptake and the least chance to enter the animal human food chain. So this is the our strategy for using AI in our work plan.
All right. So, yeah, please,
Uh,
yeah, let us
these are
conclude.
our conclusions that
Yeah.
the emerging contaminants are
We
ubiquitous
have
in the
10, we have 10 15
environment.
minutes for the discussion and question answer round. We have 10 15 minutes easily for the question answer round also.
All
Yes.
right. Yeah. So we conclude that the emerging contaminant has become part of our daily routine, and in the background, the science is being evolved to use, first of all, to treat this emerging contaminant at the wastewater treatment plant itself, and in the developing nations like India and Asian countries, where the wastewater treatment plants are not equipped with the technology to treat this kind of contaminants, we are trying to use it judicially, where it does not cause minimum damage to the food chain and the environment. So that's all we would like to conclude with. So thank you, Kamlesh, and for this opportunity. I may look little tired because there was a hassle. My flight got cancelled and the train got delayed and all because of this foggy condition. But I'm hopeful that I was able to serve the purpose.
No, it was one of the very knowledgeable and informative session. Being an environmentalist, I'm very fond of such sessions, which include human health and plants, and definitely many new things that I have gained here. And I will try to, in my future works also, I will try to use this information and knowledge. And I believe that audience must have also. It's an actually your session was an eye opener
Hmm.
because many of us are not aware about all these things. We are simply consuming the things, just a label that organica, and we
Hmm.
start rushing towards that, and we find that it's organica. But the story behind the scenes is altogether different. What we see in the front screen and what is in the back end is altogether a different story.
Hmm.
And I at times I discussed with Dr. Lakshmi Chaudhary also, and she's also discussed of how with very simple things and simple habits, she also tries to make the life more environmental friendly. Uh,
Mhm.
so definitely a lot of things. It was just an introductory session, and definitely everyone will dive into more details of these informations and sessions for a deeper knowledge and understanding.
Thank
Uh,
you.
yes, yes. We would like to open up the mic for the audience who would like to ask the questions. Deliberations are open. Anyone who wish to ask question, definitely we are open for that from the audience. Any questions from the audience? Okay. So audience might be on a tea break. I found that Calamity has opened her mic. Whether she want to ask, Doctor Calamity, do you want to ask anything? Okay, okay. So thank you very much, Deepak sir, Deepak Swami sir, for this enlightening, eye-opening session on I would say these contaminants have become the part of our life. Just like the viruses and bacteria has become part of our life, we are bound to live with them. We cannot ignore them. And
Yes. Yes.
true, true. So we end up this session here, and we'll start the next session. Uh, thank you very much, Deepak sir, and thank you, Vinay sir, for sharing the session.
Thank you. All the best.
Thank you.
Thank you. Thank you. Uh, Kiran ma'am, are you there? So we'll take a short break and then we'll again come for the last session of this FDP uh, by Dr. Arun Vyas sir. Uh, and then we'll have the feedback and assessment session in which a quiz will be circulated. It will be having 35 questions and you have to complete the quiz. The quiz will be circulated through a Google form. Please complete the quiz and give the feedback on the Atal FDP Atal portal. When you log in, you will find a feedback button on the left hand side where you can click on that and give the feedback and the assessment which will be taken by the Google form. We will upload these marks on the assessment sheet at the on the Atal portal. Please do attend these two. These two are the mandatory part of the Atal FDP. If you don't fill the feedback and if you don't give the test, and you might not get the certificate, we are sorry for that. These are the mandatory rules and regulations of the Atal FDP. You have to comply with that.
I think many people are facing network issues. So today's attendance is 75 only.
Yes,
75
yes.
people joined. Yeah.
No issue. We'll have a 5-10 minutes break, and then we'll again start with the next session.
If anyone have any query regarding the test or feedback session, you may post your message in the chat box here also. Just a minute, we are going to start. Yes, so very good evening to all of you. In the 13th session, I am heartily welcome to all of you. We have Professor Prasanta Sahu with us for this session. And Professor Prasanta Sahu is an associate professor in the Department of Civil Engineering, BIT, BITS Pilani at Hyderabad, India. He holds a PhD in transportation systems engineering from the IIT Bombay and a master's in TSE from IIT Kanpur. Professor Sahu is an adjunct professor in the Price Faculty of Engineering at the University of Manitoba, Canada. Professor Sau has been a pioneering contributor to freight transportation planning and policy in India with numerous high quality publications aiming to improve the logistic efficiency of goods movement. The foundation of his research has been the application of rigorous quantitative methods for modeling freight demand and assessing the negative externalities of city logistic operations. The model systems developed by Professor Sahu are disseminated in top tier transportation journals and are available for policymakers requiring freight demand quali- quantifications at the disaggregated levels of establishment and ports. At BIS Pilani, Professor Sahu leads Transportation Research Innovation Analysis Lab and an associate research center of the Center of Excellence on Sustainable Urban Freight Systems. Through trial and arc, he is working towards fostering sustainability efforts in urban freight transport planning and operations. He also focuses on green mobility planning, quality of life, transit safety and security, travel demand management schemes such as congestion pricing and transport emissions. Multiple projects led by Professor Sahu is this research area are currently ongoing under the sponsorship of funding schemes such as Asian Development Bank, Global Challenges Research Fund, Government of the United Kingdom and Scheme for Promotion of Academic and Research Collaboration, MHRD, Asian Smart Cities Research Innovation Network, La Trobe University, Australia, BITS RMIT Academy, Australia, UK India Education and Research Initiative, UKERI, Government of India Public Works Department, Government of Telangana. Professor Sahu serves as a handling editor of Transportation Research Record, the flagship journal of Transportation Research Board, USA. He is an editorial board member of Transportation in Developing Economies, the Journal of the Transportation Research Group of India. Also, Dr. Sahu serves as guest editor to research in transportation economics. Dr. Sahu is the standing committee member of the sub editor of 80015 Freight Transportation Planning and Logistics, Transportation Research Board, National Academics of Science, Washington, DC, USA. He is a life member of the Institute of Urban Transport, India, and Transportation Research Group, India, and India Road Congress. Dr. Sahu is the scientific committee chair for the 8th conference of the TRG, which is scheduled in December 2024 at Guwahati, hosted by IIT Guwahati. Further, he serves as an executive board member of the Transportation Research Group, India. Additionally, he is a visiting faculty to the University of Regina, Canada, and Cardiff University, Cardiff, Wales, UK, National University of Singapore. So, very very warm welcome to Dr. Sahu in this FDP. So, Mike is over to you, sir.
Thank you, Dr. Kiran, for the kind introduction. Uh, so in my presentation, I have my colleague, Dr. Bhavani Shankar Bala, who has joined from Italy, University of Rome, who worked with me for his PhD, and also my senior PhD student, Mohammad Jabiullah. So they are going to talk about how uh, the data analytics in particular has been applied for transportation planning. And in transportation planning in essence, Dr. Bhavani will talk about how it has been applied in freight demand modeling, and Jabiullah will focus on how e-mobility, e-bike mobility particularly. There are a couple of projects which they have worked upon, so they will share the real life cases. But before we go into the topic, uh, let me share my screen and briefly talk about my lab here. From there, we will move on to Dr. Bhavani, then subsequently to Jabiullah. So I hope it is visible. Uh,
Yes, sir. Yes,
okay.
sir. Visible.
All right. So at BITS Pilani, Hyderabad, we have developed a lab called Transportation Research Innovation Analysis Lab, which in-houses different ongoing projects which are funded by international agencies as well as government agencies in India. And this lab in-houses about 12 PhD students and 8 master students. And through our research, we have partnered with many universities all over the world, and those universities you can see them in this map, from Europe to North America to Australia, and some of the recent work also has been initiated with a couple of universities in Russia as well as in the Middle East. And our major funding agencies who have funded different projects. One among them is Asian Development Bank, which is a large value project, which is focusing on developing a transit application to ensure safe and secure mobility of the commuters. And the other funding agencies are Volvo Research Education Foundation, Sweden, and the Global Challenge Research Fund, then a Ministry of Education through the Spark Stream, and recently also ICSR through Viksit Bharat program, we have received another project which focuses on public bicycle sharing. So essentially, the trial is working towards fostering active mobility and green mobility in both for freight and passengers. So these are some of the projects which are in progress. One is, as I told, the Asian Development Funded project, which is known as TUITEM. That's a transit application, essentially, which will provide a safer and secured route while traveling. Then there was another DST funded project which we worked upon, ensuring the traffic safety, to identify different potential locations and recommending the mitigation measures there. Also, we have a couple of more projects on virtual reality and augmented reality. These are more technology-driven projects. And the latest one, we are working on developing another application for public bicycle sharing. And we have just finished this project on congestion pricing, or to develop different travel demand management schemes to reduce congestion as well as subsequently reduce pollution to make cities more livable. This is a snapshot of those projects where, if you can see this picture, where we are developing an application which we refer as technologies for urban transit to enhance mobility and safe accessibility. In short, JIET. And this snapshot is telling you what kind of technology we are developing. Similarly, other projects are in, and also we are working with RMIT and Latrobe University through two different funding schemes to develop uh, food security by integrating the supply chain, securing the food security rather. And the research which we have done for the last 1 decade has been disseminated in all tier one journals in the area of transportation, freight and logistics. My One of my first PhD student, Dr. Agnivesh Pani, who is a faculty at IIT Varanasi at present, who worked on extensively on developing freight demand models. And this is the very brief or visualization of his work. And his work also received the best paper award by Transportation Research Board in freight and logistics in 2020. Subsequently, after the model development by Dr. Pani, then Dr. Bhavani uh, worked upon developing models to transfer those models so that the resource management can be done. Essentially, he developed different transformative approaches which are data driven, used with the use of different algorithms that is quite well known in the area of data science. Uh, so he developed different transfer approaches, how to transfer the model with without compromising the accuracy in case of resource constraint regions. So he's going to talk about that more in detail. Then the second work which will be discussed by Mr. Javiula, who is my senior PhD student, that's on e-bike mobility planning for smart cities. And this project was inspired by the United Nations Sustainable Development Goals number 3 and 11, which is health and cities. So here, the entire the project will try to develop how to reduce the traffic congestion and carbon emission, and thus by improving the health standards of the commuters through uh, e-bike planning. So with this, I would like to invite Dr. Bhavani to, I'll answer my screen, and he's going to present about how to use efficiently the data analytics for freight transportation planning.
Thank you, Professor Sahu. Let me share my screen. Uh, Before I get into the presentation, am I audible?
Yes.
So, before I get into the presentation about artificial intelligence and machine learning, what are their applications in sustainable transportation, especially the freight transportation? I would just like to ask the audience, I want to make this an interactive session. First 10 minutes, I would like to know the opinion of what opinion of the audience, what comes to their mind when they hear about artificial intelligence and machine learning. What you can do is you can just scan the QR code here, just scan it, or you can even use the link, whatever the link is there. You can use the link. Let me just put the link in the chat. Yeah, I have put the link on the chat. Uh, so go through the link there. Then you'll find a survey poll there. Okay.
The question has appeared, but there's
And
no way to answer or okay, enter a word.
to
Got it. Enter a word.
enter that.
Many of them are replying in the message box.
Okay, fine, that's okay. You can give more than one word. It's not that it's like you have an option of entering multiple words there. As soon as you enter, you can also enter other word there. I was expecting Chat GPT here, but yeah,
Sarvan Chandra has also replied in the message box. Vidya Ramesh also.
just 5 more minutes in case if you are open for answering the question. Okay. Okay. Uh, yeah, we see a good number of participants here, and we see that most of them look at automation when they hear about artificial intelligence or machine learning. What comes to their mind is automation, and next thing is advanced technology. This is what most of us think about. Yes, this is true, but what else it can be? So yeah, I was expecting some creative answers. Okay, fine. Let me tell you what else it can be. Yes. So, what comes to my mind when I hear about artificial intelligence and machine learning is the movies here, The Matrix and The Terminator and the Robo movie. So, the Matrix movie in which the architecture uh, of a computer, a particular gaming was done. It's all about you need to understand the architecture of a gaming and how it is done and everything. So this was the imagination of that director or the storyteller a long back ago. And similarly, the Terminator is also same. And even the Robo movie is also the same thing, like a advanced humanoid. So my work was also inspired from a movie called Triple RRR, which is an Oscar-winning movie. So now let me tell you what really I have done in my PhD. So myself, Bhavani Shankar Balla, postdoctoral fellow and project scientist at Transportation Research Lab, which is also known as TRI-Lab, TRE Lab, and it is in the Department of Political Science in Roma Tre University in Rome, Italy. So now my postdoctoral research background, my thesis was on transferability approach for freight data measurement and model development in resource constrained regions. So it's more about developing freight demand models, considering the resources, mainly about what resources are about, the survey resources. So this was about. So these are some of the research questions what I answered. What are freight trip generation models? What is the need? And what is spatial transferability and why spatial transferability? And so the type of models I have developed are freight trip generation models, or it's also freight generation models. So it's all about estimating the tonnage there. And why we need these type of models? Because there is quite population exploitation, the demand for the commodity is increasing, and also the manufacturing is increasing, due to which the vehicular movements, especially the truck movements, are increasing, which is causing air pollution, traffic congestion, and also that deteriorating payment design. Payment We need a new payment design for that. So for this, in order to understand the models, estimate the models, and understand them, we need the data. But unfortunately, we don't have any data related to that. So, what is spatial transferability? So, we are using this concept of spatial transferability to minimize money, time, and manpower required to collect the data related to freight. This was what the entire background about. And what motivated me is 3 R's, as I already said. First R is about the resources. In foreign countries like US, for collecting one response, it nearly costs $120, and in Canada it is $190, and Paris and France it's $500. So now the long survey time, it's the survey time is also very long. It's like it ranges from 30 minutes to 120 minutes. And also for this, we need a lot of skilled enumerators. And especially this type of survey is unique, and it's like maybe India is one of the countries that is, especially the trial lab is one of the labs in India across. It's not just in India, across the globe, which has conducted such type of surveys. So it's because the reason is collecting data is very challenging. If you look here, you can see the eliminator condition here. Like if someone is interviewing, so they have to wait for very long time. Even after waiting, it's very challenging to get the response. So on day one, when we have conducted the survey, so day one, the interviewers were all our master students. So day one, they were happy to come, but day two, they were a bit unhappy. And by the end of the day, that is like by the end of the week, they were quite unhappy to collect the data. This what happens because it's very challenging to conduct. You may be surprised to know that very cities like Rome, in which I'm staying now, residing now, so they don't have this types of survey now. Now they have started conducting this type of survey in order to understand what is going to be the freight demand. And next one is the responses. I have started my PhD in 2020. And during that time, what happened is there was lockdown due to which all the industries were also closed. So I did not have any data to collect. So in order to do that, uh, I needed a bet, no responses at all. So I was thinking whether what can be done, whether the already available data or any other country's data or any other region's data can they be used for estimating the demand, freight demand in other cities. That's what is the next motivation for me. And next is respondents. When you go and ask someone, interview, usually this interviews, the data collection is the face-to-face interview. When you ask responses, that is when you interview them, they're quite, uh, they don't respond immediately because their first thing is, first reason is when you ask questions related to their business, so that hindrance to respond to you, considering that you are from some government agency or you are their competitor there. So this is what was one of the other motivation. So these three are what motivated us. Now, what had been my contribution? So from RRR, my contribution had been MMM, the three M's. So it has been modeling, model transfer, and measurement there. And what was contributed? First contribution was I have developed freight generation models or freight generation models at various levels, state, regional, and industry. Then data-driven industry classification system based on establishment's freight characteristics transferable. Then that is, I have created a special industrial classification system based on statistical methods. And next is I have assessed for the transferability, whether a model of one region can it be applied to other region or not. That was done. Then this transferability, that is when the model of one region is being applied to the other region, whether it has some effects. What are the factors affecting that transferability or application? Those are the factors what we identified. Then the most important thing is we try to minimize the survey resources in terms of money, time, and manpower using this spatial transferability approach. The flight data was collected from various cities: Jaipur, Hyderabad, Kannur, Malappuram, Palakkad, Kottayam, Calicut, Thrissur, Kochi. And this was establishment-based freight survey, EBFS. And so this is a face-to-face interview. And the respondent was the person whom we interviewed was employee who takes logistic decisions at the industry. And the data was collected at the establishment level. It was not the entire district data was considered or any entire city data was considered. It was the establishment level data, that is the point data. So the first one is the creation of accurate, it's not creation, development of accurate flight generation models. So we have used two modeling methodologies here: broad classification, parametric models, non-parametric models. Then levels, state level, at various levels, state, regional, and industry. And we have analyzed different modeling methodologies here. Next is data-driven industrial classification system. That's what we have created here. So this is we have in this study we consider the fleet ownership and period of formation and various other factors of establishment. Instead of considering the commodity, we consider the industry and its characteristics to classify the industries. In past, there are studies or there are statistics or classification system which define the entire industries based on the commodity. That is food industry. That's for example the food industry and the cloth industry, so on, textile industry, and so on. So instead of that, we have considered the characteristics. That is, what is the area of the establishment and what commodity it is producing, not just depending on the commodity, but also many other factors based on which we have developed the industrial classification system. Next is the transferability assessment. So urban to suburban transferability assessment was done and suburban to urban. The transferability assessment was done. And also one of the factors, what samples has I discussed, what sample size effect is on the transferability. That's what we have assessed for. Then we try to minimize the freight survey resources, especially in terms of so this is what MMM framework. So for measurement, modeling, and model transfer. So data collection, so model development, and so measurement, modeling, model transfer. So what was done here is we have collected the data, which is the first step, the measurement, and then we have with the data we have developed the models, the model development. Then we have developed model for one particular region, and we have assessed whether that model can be used for the other region or not. That's what we have checked for. That's what we have assessed for, which is known as model transfer or transferability assessment. Then also apart from that, we wanted to see whether these models can be used for other regions where data is not at all available. There is zero data. So for that, we try to identify the geographically similar regions there. For that, we have used different statistical techniques and we have come to a conclusion about sample size. So in the new region where the data is being collected, in that region, the amount of the sample size required is very, very small compared to our conventional methods of sample size calculation. So with this methodology, it's like we have saved at least 80% of, we have reduced by 80% of the sample size required. That's what we have done. So finally, the objective was overall to understand all these things. So from measurement, first the sample size, then the modeling, then from model transfer, the spatial transferability back to the sample size calculation. So these are some of the studies which I have done in my PhD. Now, now AI, urban innovation, and sustainable growth. So as soon as we look at this topic, so what we understand, as previously I have shown, the only models. And also, if you look at the word cloud, what we see automation. But what really is what really we need, what applications can be done as artificial intelligence. And so it's sustainable growth. So usually people, when they talk about sustainable growth or sustainable cities, smart cities, they usually talk about electric vehicles like e-bikes, uh, and electric cars and electric trucks and so on. But in order to implement such policies related to electrification of any freight fleet or any passenger transport, what do we require? Is it just the models or do we require something else here? So that's what we were trying to explore at present, and that's what the research is all about. So before going to some innovative techniques of sustainable growth, let me introduce to artificial intelligence and machine learning. So if you look at different generation of computers, the first generation, second generation, third generation, fourth generation, now we are in the fifth generation. So first generation, it's about the vacuum tubes. So all about the vacuum tubes, very large in size and everything. Basically, the computer was invented for computations there, that is for the calculation purpose. Then, since the size is very large, so they try to reduce the size using transistors. That's the second generation of computers. But what was observed is vacuum tubes and transistors were generating very high amount of heat. In order to reduce that, the third generation of computers, in which integrated circuits were used. So, using the integrated circuits, the amount of heat generated or disseminated was very, very small. And but the commutation time was very, very high. In order to reduce that, next generation of computers have were manufactured using microprocessors. Even now we have microprocessors, but this generation microprocessors are known as very large scale integrated circuits or ultra large scale integrated circuits, which are known as ULSI. And also now in the fifth generation, what we have is artificial intelligence. So now what is AI, ML, and deep learning techniques? So artificial intelligence is overall a larger, a broader area of research there, or any in terms of broader, you can say it's a broader domain, in which machine learning is a subset, and to the subset of machine learning is the deep learning there. So artificial intelligence has, in the word cloud, has the respondents as given. So it's more about the program, coding, algorithm, complicated, and deep learning, many layers, and so on. So now instead of the theory, now let's see what can be done in the artificial intelligence. So let's see how this is different from the traditional programming, how the machine learning or the artificial intelligence is different from traditional learning, traditional programming. So in the traditional programming, what was done is we were giving the data there and the program. That means program in the sense we are giving the logic or the algorithm in the computer direct. For example, the C language, the Q basic, beginners all purpose symbolic instruction code, COBOL, so on. Many programming languages, Python, R, and so on. What we are doing is we are just giving the data and giving the program, and it's giving the output, like adding two numbers, multiplying two numbers, or multiplying multiple numbers. So we are giving the data there, and we are giving the program. That is, we are giving the operator there. Then we are getting the output. So product of numbers, the sum of numbers, and so on. But in case of machine learning or artificial intelligence, it's different. We give the data and output, and we get the program there. That means we are giving the data completely. Whatever data we have, we are just giving it, inputting it, and we are giving the output also there. So if this is the input, what is going to be the output? Even that thing we are giving. We are giving both together, and the machine is learning itself. Just like human learns, the machine is learning itself, and it is coming with a logic. That logic is nothing but the algorithm there. In the sense, it's algorithm or the program there. So now this is what is the difference between the machine learning and the traditional programming. So what are the benefits we get from machine learning? So first, automation. This was what was seen in the cloud there. Automation. Most of you have replied that it is automation. So this is what is the most interesting part and the most beneficial part of the machine learning or artificial intelligence. And also, we rely less on the human interaction here. That's what is one of the benefits. Then, with machine learning and artificial intelligence, there are high chances of increasing the accuracy of the results. So, this is what gives us scope of improvement in the present conditions of the cities, making the present cities from the ordinary cities or just normal cities to smart cities. So, this is one of the benefits of AI. Then, in case if you have very large amount of data, not just storing it like in case if you see the old generation of computers or personal computers, we used to store it in floppies initially. I don't know whether how many of you have really seen floppies. Then we have come up with CDs, then DVDs, then pen drives, and so on. Then now we have even cloud. Then how this cloud is being handled? We are using artificial intelligence and machine learning to handle all this data through cloud storage. That's how the data is being handled. And not just the data is being handled there, and also it's being processed and analyzed using the artificial intelligence and machine learning. And apart from these four benefits, we also have wider applications of machine learning and artificial intelligence. These are some of the applications of artificial intelligence and machine learning in transportation, self-driving vehicles. So these are like driverless vehicles. So and you could see these driverless vehicles soon in the market. They're still in the testing stage. And next is the traffic detection. So for example, we just install certain CCTVs on the roads, and we try to capture the traffic, and we try to analyze the traffic. Instead of just counting it manually, we just try to analyze the traffic. It it's like it can be in two scenarios. One scenario is it's like the the cameras or the CCTVs are directly integrated with the hardware, which detects the type of vehicle. That's one of the, or it's like it records. After recording, the video is analyzed in the laboratory to find out the vehicle type here. Then even the pedestrian detection, how the pedestrian movements are going, all this, and the traffic flow. And most important one is the parking management. So in the European countries or in Canada and in US, in these countries, what we see as parking is a major issue. So for that reason, and it's for that reason, so they are using artificial intelligence for they call it smart parking here. So that's what they're doing. And apart from this, the road conditions are also being monitored. So what is the crack? So these cracks on the roads are being visualized and being processed Then, based on the width or the type of crack, the way we take a decision as an engineer, the computer or the machine is taking the decision there. So, what type of crack it is, and what caused that crack, and what measures can be taken. That's what can be seen in the case of root condition monitoring. Next is automatic traffic incident detection. So it's the in case of this is like more about what we see as in case if there is some accident, what caused the accident there? So whose fault it is? Is it the driver's fault, or is it the road? Is it the geometry of the road what's causing the accident? All this can be recorded, and this detections can be also uh, uh, first all these are detected, then they are integrated into a cloud there. Then based on this, the cars are automated for detecting the traffic incidents. So in case if there is some car before us, so our car will be in a position to detect based on our speed, or it can automatically reduce the speed automatically based on its previous experience what we had through the monitoring of the clouds there. Then and also it's like automatic license plate recognition. So this what we see here. So for finding and for identifying certain crime incidences. So instead of deploying so many police or man force, this was what being deployed. So cameras are being installed, and with the cameras, the license plate based on type of crime or any violation of traffic rules, it detects and automatically sends challan or the fine to the driver or reports to the police based on the incident. So then driver monitoring. So also it's like this is what is being done now. So how the condition of driver now, especially in terms of safety, whether the driver is in a position to drive. So when he or she is a driver and driving for a very long time, what condition he or she is in? He feeling drowsy, that is being detected using the cameras which are installed and the vehicle and being collected. So now I'm just going to show one of the examples of what are the applications of traffic signal detection here. So I'm just going to play the video here. So we can see that the traffic light is being detected, whether it's red or green, that's being detected here. So this is what artificial intelligence is doing automatically. So from red to green, it is be able to recognize. This is what is one of the applications. This is wanted to demonstrate here. So now, let's look at what can be done in obtaining sustainable transportation, especially the freight transportation. How can you make a city sustainable using artificial intelligence? That's what we are going to. So, and what comes to our mind usually the sustainable is the fleet electrification is what comes to our mind. That is reduction of emissions. That's what comes to our mind, and all these things. like changing the complete vehicle infrastructure, like what infrastructure we need in case if we are going to have the electric vehicles in our city. This is what we think about mostly. But is the electrification is the only solution for sustainable solution? That's what we are working about in the trial lab, the lab in which I'm working. So, you would have seen I have mentioned certain things in the start of my slide about the movies and everything. So the reason why mentioned about movies is now let's see that before going into the theory there, I just want to just show you something interesting. How artificial intelligence can cause to the failure there. So there has we have the brighter side and also we have the darker side of artificial intelligence. That's what we are going to show. That's what I'm going to show you now. So this is what Amazon was planning about, which is Amazon Go. Okay. So can you listen to the audio there?
Yes, sir.
Is the audio visible? Okay.
Yes, sir. Audio and video both are
Okay.
accessible. Sir, now audio is we are not the video is not audible to us. Sound.
Okay, video is not audible. That's fine. I'll explain what really this video is about. You just look at. I just want the audience, the participants, to look at the video there. Okay. So if you look at the video here, so Amazon st- started a store called Amazon Go. They wanted to have a cashierless stores. So for that reason, they have used deep learning algorithms and various other algorithms for which the data was collected using the visualization techniques. So this visualization was done by capturing certain videos there. So Amazon wanted to start this in 2017. The idea was to start in 2017, but it failed to start in 2017. The reason was it could not really analyze the consumer behavior. So whoever developed this, they have not considered they could not really understand the consumer behavior here. So, in order to understand the consumer behavior, they tried many techniques, many models, many interviews, many data collection methodologies, many things, but still they were not successful. And finally, they thought that they were successful and they started it after COVID in 2020. But when they started it, still they were not successful because the idea was initiated in 2017, but really the stores were established in 2020. When they started it, what happened is the the customers entered or the consumers entered into the store and their behavior was bit different what these machines could not learn. So we think that the artificial intelligence is the only solution that can be done, but can be it's like automation can be done, as we have seen automation can be done, but they could not automate everything. So when the consumer entered, his behavior was different. His purchase behavior was completely different. So since his behavior was different, it could not capture it, but still they failed. And whatever to be built, either the customer was billed more or he was billed less. So this was what happening there. So after in 2021, what Amazon has done is instead of having cashless counters, they have put a cashier there. So finally, they were back to what is called the traditional method. So they have not completely automated. They are back to the traditional method of cashier. So this one of the reasons just I want to mention is when we go to a store, we just purchase something. For example, if you are purchasing vegetables, how can those vegetables can be weighed? So, what is the weight of those vegetables? That was not considered by Amazon's algorithm. So, it can be just, they would have just picked one apple or two apples or whatever it may be. How the algorithm is going to recognize that. So, here, even myself, when I go to a store here in the room here, there are many supermarkets. I go to the store, there are different types of apples there. Instead of purchasing one variety, I just pick one apple from each variety. This is my behavior as a consumer or customer there. Similarly, the other's behavior is completely different. The other customer's behavior is different. So we really don't understand what is the consumer's behavior. This is one of the darker side of the artificial intelligence or the disadvantages of the artificial intelligence. So in order to introduce more, in order to have more type of intervention of the human intelligence into the artificial intelligence, there are certain other techniques what we are currently working on. The one of the techniques is storytelling. So, for example, if we have a city, complete city, and we want to understand the consumer behavior, based on the consumer behavior, the freight, that is the truck movement is seen. So, in order to understand that, what can be done? So consumer is just one of the stakeholders in urban logistics. The other stake, the other stakeholders are the logistic providers and the manufacturers and the different like end users and also the receivers there. So and also the policy makers are also involved. there are numerous number of stakeholders involved in this. So our approach was, so that's the reason in the introduction of my presentation, I just told the movies. So it's that's the reason I introduced the movies. Movies is all about the storytelling. What makes us these movies interesting is the way they tell the story. So we tell similarly we tell these stakeholders a completely interesting story in order to make them use sustainable transportation. For example, we create a very interesting story, not story in the sense you can consider the movie, but in the broader domain, this concept is known as storytelling. So, a movie based on artificial intelligence. So, the storytelling based on artificial intelligence, where the intervention of the human and artificial intelligence both together, they come up with a final solution about the urban logistics here. So the storytelling is completely different for a stakeholder who is a policymaker. It's like teaching a seventh standard student is different, and teaching a engineering student is different, and teaching a PhD student is different. That's what we experience. So similarly, storytelling for each stakeholder is going to be different, and also based on choices what he make or based on his past experience, we are going to ask some questions to him, and we are going to capture his past experience and all his responses, and we are going to make a new story out of which we are going to finally make a sustainable transportation there, and we are going to finally give a solution to the policymaker. So this is the intervention of both artificial intelligence and also human staff. Here in this case, for sustainable transportation, sustainable urban logistics, it's more about the intervention of the stakeholders. So this is one of the concepts what we are working on. And next is the most interesting thing, the gamification. This is the second interesting thing what we are working. So we so in order to have sustainable transportation and to make a sustainable city, it's not just we need to promote the sustainable transportation like subsidizing for subsidizing the vehicles or different policies, implementation of different policies, and so on. It's in order to create awareness into the users or different stakeholders what really the sustainable transport is about. So, so there are different communication methods, different communication strategies. So usually we see that the government is promoting the sustainable transport like electric vehicles while advertising it or even subsidizing. So these are different communication strategies, out of which this gamification is also the other strategy. So we are trying to transfer the knowledge of what really the sustainable transportation is through gamification. So we are going to create a game which is based on artificial intelligence. So integration of artificial intelligence and a human intervention, uh, both together, a game will be created where the human or the stakeholder will be given certain challenges or certain things which I cannot reveal at present what we are really developing on. So we are giving certain set of goals to them, and we are trying to understand what they are doing, what they really need from us and trying to understand. And we are trying to implement that in terms of gamification, game there. So, what one of the things what we have done recently on 24th October, we have presented a game there. It's a board game. You can see a board game here. This board game is more about the competition between the stakeholders. So, what we have done is we are trying to have four types of stakeholders here. One of the stakeholder is the decision maker. So in this game, one is going to be the mayor and so on, the logistics provider and so on. And they have set of questions and they need to answer certain types of very simple questions that are not very complicated. So these type of question, based on these types of questions, we are able to understand when someone plays the role of a policy maker, what he's going to do. That is, in future, if someone is going to become a policy maker, what is going to be his knowledge about sustainable transportation and how he's going to take a decision about creating sustainable logistics. So this game was designed for the kids, the school kids initially, and it was presented in Maker Fair 2024 in 2000 in from 25th to 27th October. So usually in this fair, very creative projects, especially the international projects, come together and they many universities across the globe come together and they organize it, especially the European countries come together. So this game was just an initiative to plant the knowledge of sustainable transportation into the kids, school kids. So this is one of the methods what we are using, and also it's like we can see that the gamification has been introduced now. People are switching over to the gamification here now. So this is second innovative technique where we have intervention of the artificial intelligence and also human intelligence here. And the third one is the digital twin. So here the digital twin, so we quite hear about the digital twin here. So as previously said, the Amazon Go example there, we are unable to understand the consumer behavior. So we need to analyze the behavior of the consumer. So what we do is we try to collect the data regarding that and everything regarding the consumer behavior. So how they are behaving in a particular store, like in a textile store, how they have behaving, and in terms of different things. So yeah, different stores. Yeah, you can name any store there. So how this is one of the examples how they are behaving there. So we try to model that. For that, we need to collect the data. We try to model that, and we try to model that, and not only behavior of the consumer or the customer there, and also we try to put various behavior models and various decisions, and all together we are going to model them. So all these models, that the mathematical models, are put together and we are going to create a digital city. That is, we are replicating a city in digitally, which we are calling as digital twin. In that digital twin of the city, you can see the how the movement of the passengers is, how the passenger, not only passengers, how the truck movements are, and all the mobility and everything can be visualized. This may sound similar, to the softwares like Visum, but digital twin is completely different. It is completely different, even though it is a visualization technique, but the models used in digital twins are the mathematical models, or the real-time data is being collected and being developed. So that's how an entire city is created. And what can be done using digital twins is, I'll give an example of what can be really done using digital twins. So, for example, a government has implemented a policy initially related to urban logistics. So, how the behavior is changing? When the behavior is changing, what are its impact on the truck movements? And when so truck movements, it's not really we are looking at the truck movements. It can be considered as what are the environmental effects. So the consumer behavior, how it's impacting the truck movements, and finally it is the emissions. So that's what we are going to assess. So if one policy is introduced with the present behavior, how it's going to change. And after 10 years, when a different policy is used and it's being implemented for 2 or 3 years, then how the behavior has changed. This comparison can be done using the technologies like digital twins. So create a digital city, and we can have and we can just look at how it can be modeled to have a sustainable city. So these are the three interesting things. First thing is storytelling, next one is the gamification, and next is digital twin. And this, in case if you want to have an idea about digital twin, you can look at one of the European projects called the LEAD project, which was done in Europe. There were many institutions involved in that, maybe around research institutes, maybe more than 30, I guess. I'm not sure. You can just browse it and see what they have created. So our role in this digital twin was, as a freight researcher, our role was to give to understand the behavior there. It's not just one stakeholder like the consumer behavior, all the other stakeholders' behaviors. So for that, what factors to be considered? What are the inputs that should be given to this digital twin? That was our role. And next, our role and next thing is this digital twin, in order to develop this digital twin, that is to model everything, to visualize it, to develop the digital city, it was given to our industrial partner. There are many industrial partners. One of the industrial partners was Last Mile, which has developed this digital twin. And finally, this was delivered. Digital twin was delivered, and you can. This is available on the lead project. I don't remember the website, but it's on the website. This digital twin is available. You can just access it. So, so thank you now. These were the things I was just wanted to convey. Yeah. Any doubts in these? Any questions?
Okay. All right.
Participants,
Vani.
participants may ask question by unmuting mic.
Let me unmute the mic of the participants, ma'am.
Yes, sir.
Uh, Dr. Saranachandra had a question, and he was asking if gamification is about understanding of psychological behavior of stakeholders to better implementation of sustainable transportation logistica. he commented on that
Okay. So
about the
the
gamification.
gamification, yes. So last year, I guess it was last year, I guess in 2023. So uh, there was a paper on gamification. Yeah, you can read it on TRR, Transportation Research Record. It's not just about, we are not just limiting about, uh, it can be, see, any game, it need not be just a board game. It's like we have different types of games, like sports, different sports. So this gamification is more specific to what requirements we need, and it is designed based on what goals we need to meet. And it's not just to create awareness; it's also for other purposes. What we are working on at present.
Okay, Geeta Tiwari has a question.
So essentially, Kamlesh, let me,
Yes, sir.
essentially gamification is a way of simulating the real life cases which will help you in decision making, not necessarily to be on freight and logistics, because freight and logistics have multiple stakeholders. So if you see how the entire supply chain works out, and because it is very sensitive, gamification is becoming popular while making the decisions. And the stakeholder, if I look at how the freight flows, it carries a hell lot of information, lots of money, which is very, very sensitive. So therefore, gamification is a modern approach to simulate their entire decision-making process so that if I talk about only logistics, I can entirely optimize the supply chain network.
Yes, sir. Yes, sir. Definitely. Uh, Geeta Tiwari, you had a question. You may ask directly. Geeta Tiwari, you have raised your hand. One question. Okay. Any more questions from the audience side? So I have a question from my end before audience could ask anything else. Uh, like I am from Jodhpur, and Jodhpur is a very traditional city. So there is a huge heterogeneity in terms of vehicles, in terms of the width of roads, in terms of the behavior of people, in terms of the awareness of the people about the traffic rules and regulations, and all this we are facing. So, as in the beginning, you said that the implementation of AI in transportation and mobility. So, is it really feasible in such cities which are old, which are holding so much of heterogeneity? So, is it feasible at this stage to implement these things, these AI tools in these cities, or still there is a long way to go?
Okay. Hmm.
Rohan,
So,
you would like to answer? Yeah,
sir,
go ahead.
just few. Yes, sir. So it all depends. AI can be implemented anywhere. So it all depends on which AI tool can be implemented. That's what is very important. So based on the conditions of the city, so heterogeneity of the traffic and so on. So what can be done? How the artificial intelligence can be introduced? It need not be always a smart infrastructure like smart charging technology. It can be also sometimes uh, the AI based models which can give us a better solution and also decision in terms of policy making. So the present roads heterogeneity is fine. Sometimes the policies itself give show a major impact on the way the mobility is, or the urban mobility or the passenger mobility is. So this is one of the things. So it can be implemented in any city.
Yeah, it all depends on which problem you would like to address. So if you talk, heterogeneity is everywhere. It's not only in Jodhpur, it's all over the world. The question is, how do we define heterogeneity? That all depends on. So if I give an example, let's say Jodhpur, you want to reduce accidents. Crash mitigation strategies you want to make. You can use, if you have crash data with a larger scale. So easily I can use any AI-based tool to predict the probability of crash given a location, given the traffic volume, given the built environment. So we can use.
Right, right. Actually, I was saying in the context that in the Western countries, much of the things have been standardized. The way the people follow the rules, uh, and the way we people take traffic rules. In that context, I was saying.
Yeah.
Okay, Sarman Chandraji has raised their hand. You can ask Sarman Chandraji. You can directly ask.
Sir, good evening, and thanks for the info from Bhavani sir. I'm very much fortunate to listen his words about AI implementation and all regarding this logistic traffic and everything. Uh, and my question is like, how can we implement like just now Kamlesh sir also like asked about Jodhpur city. My thought of this is like we can see how China is doing because China is also a populous country like us, like India. We cannot compare with West because they are less populated than India or China. So we can see how the Chinese are doing, and we can implement similar kind of things. Uh, like I want to have a an answer from Bhavani sir regarding this.
But what is your question?
Is it feasible to take the leap from Chinese?
So it all depends what your government wants to take as a policy. Where do adopt? We don't have to take anybody's example. You have to solve the problem locally because the problem is local problem. The concept you can bring and borrow from somewhere, but you have to customize which will cater to the local problem. So it's more complex.
True. Generally, at times, we are biased to have answer like yes or no. Yes. So, as human tendency, we always want answers in these terms, binary answers. Either you like it or not, we can do or that or not. But at
Mhm.
times, the answers are very complex. They are both ways or they are no ways.
Yes.
Okay, okay. So, thank you very much, sir. Prasanth House, sir, and Bhavani Shankarji for such a wonderful presentation and that case study of Amazon. It was really impressive. I like that. And definitely in India, we may also have such stores which can save a lot of time, especially in urban cities where population congestion is too much, where people don't have time, and even they have time, they want to spend with their families. So it can save a lot of time there in the metro cities. Where it's very difficult to find time for family. So that saving of time can be utilized somewhere else with the family or in their recreational purpose. Uh, so thank you, sir. Thank you very much
Uh,
for this.
Thank you. Thank you all. It was a pleasure talking to you all. And thanks, Bhavani, for the very, very detailed approach for solving the urban problems. What approach Dr. Bhavani has discussed, digital twin is very, very popular. And it's a very simple thing. If I want to define digital twin, it's essentially simulating a physical world to your computer. So thank you all for listening us, and hopefully we'll find out some more avenues to interact with you all.
Thank you, sir. Thank you
Thank
very
you,
much.
sir. Thank you for spending your valuable time with us. Thank you very much, sir.
Thank you. Thank you, Dr. Kiran.
Thank you, sir.
Bye.
Bye.
So, ma'am, this session is for the feedback and quiz session. We will have a feedback for 10-15 minutes. We can have a feedback and then we can have a quiz. So, quiz will be taken in Google form, and I will send the link in this chat box. Uh, so, can we start the feedback session? Uh, Kiran, ma'am.
Yes,
Yesterday
sir.
night.
It's 6:29. So share the link, please.
Okay, ma'am. Uh, I'm sure. Ma'am, first we can have the feedback session, then we can start the quiz.
No, no,
Otherwise,
parallel. Both the things will go parallel, sir.
ma'am, then
Or
audience will
first
reply, or
30
we will
minutes,
skip the quiz.
or first 30 minutes. Give first 30 minutes for the test, and then after we will start the feedback. First test, then feedback. Okay.
Okay. So I'm sharing you the link of the quiz. You please attend the test, and then at 7 p.m. we'll start the feedback of the session. Okay. So thank you. I'm sharing you the link in the chat box. Yes, Shravan, you want to ask something?
Sir, my attendance is not yet updated, sir.
Uh,
For last 2 days, now, sir.
Yes, ma'am. Yes.
Yes, sir.
only
Yes, sir. We will update it within 2 days, sir. Please. Do not worry about it.
Okay. Okay. Thank you.
Amit Mandal, sir, you want to
Yes,
ask
ma'am.
something?
Actually, yeah, I want to ask actually my last 4 days attendance is not accounted, I think.
Your 4 days. Okay, I'm checking. है ना?
Yeah.
Within few seconds, I will update
Hmm.
you. Kamlesh, sir, please share the link.
just a minute.
Ha.
Excuse me, ma'am.
Yes, ma'am.
Hello, ma'am.
Yes,
Ma'am, can you send the yesterday's Chetan sir PPTs, ma'am?
sir, ma'am. We will give all the PPTs to all of you. We will share through the mail, as well as we will share through the WhatsApp group. All the sessions
Okay.
PPT.
Okay, ma'am. Thank you.
Aisha Amin, ma'am. Okay.
No,
Sakshi
good
Ranavat.
evening.
Okay.
My attendance is also not being displayed, madam. Kindly please.
Ma'am, I'm just checking, you know, and I will give you the update. Amit Mandal.
So I've shared the link of the FDP. Sorry, assessment link. You all may please join. Fill the attend the assessment, and then we'll have a feedback session.
बंद करना है और अंदर रूम में रहे रूम में लॉक की
Shakshi, you want to say something?
Sir, my attendance is not marked yet. It is still showing absent.
Have you filled the Google form?
Yes, yes, sir. I have filled it.
You are saying about last 4 days or these 2 days?
Sir, last 4 days, and I was trying to check on Atal portal also, but it was not logging. There was some problem in just logging also. But today I was able to do so in the evening only. So when I checked, it was showing absent for all the days.
Do you drop a message in person in the WhatsApp?
Yes, sir. I have dropped already the message. I have dropped with I'm affiliated to Purnima University, and I've already dropped shared the information regarding this in WhatsApp group.
Definitely, we'll look into the query, ma'am. No issue. Please don't worry.
Okay, sir. Okay, sir. Thank you so much, sir.
I request all the participants to please attend the assessment, the test, which has been, the link has been sent in the chat box.
Kamlesh sir? Kamlesh sir, am I audible to you?
Yes, ma'am, you're audible.
Amit
Sir,
Mandal.
sir, please start the feedback session.
So to start with the feedback session, I'm requesting all to please on your camera. All the participants, please on your camera. We'll take a screenshot. Requesting all the participants to please on the camera. Let me have a screenshot for every one of us. Just a minute. Save. Okay. So I've taken a screenshot. That's okay. Save.
Sir, pin me in the top second to you.
Just a minute. Okay. So I have taken the.
Sir, please pin me.
Okay. So, yes, I'm taking the screenshots. Yes, ma'am. What you were saying? What are you saying? Tell me, what are you saying?
Pin me. Pin me.
Yes, ma'am. Just a minute. Okay. Yes, ma'am.
No, but so tiled in the tile view.
Yes, ma'am. You are pinned, ma'am. I pinned your chat. I mean.
No. I don't want this. Sir, unpin me. I'm not able to.
No, you pin yourself from your end. That would be okay.
I'm unable.
You are the host, ma'am. You can
Yes.
do it.
Yes. No.
Should I pin you again, ma'am? Hello.
Yes. But in the yes.
Ma'am, I have
Yes,
pinned.
sir.
Okay, I pinned you for everyone. Now you can speak, ma'am. You are pinned for everyone.
I do not want to speak. I do not want to speak for the camera.
You can share your screen if you wish to. So we can start.
Just me. Kamlesh sir, unpin me, please. And have you taken the
Yes,
screenshots
ma'am.
of all the tiles?
Yes, I've taken. Ma'am. The screenshot has been taken.
Okay. Okay.
Shall we start, ma'am?
So, yes.
Okay. In these feedback sessions, the participants are required to give their feedback regarding the sessions, the pros and cons of the FDP, the session which you like the most, what additionally you want for next FDP, or whatever your feedback is regarding this FDP, what you have learned, what new things you have come to know. So you have to start the camera, and then you can give your feedback. Yes. Dr. Kalaimathi, would you like to
Satyajit?
start? Kalaimathi, would you
Sir
like to
raised
start?
his hand.
Yes, sir.
Okay, okay. You want to say something? Yes, ma'am.
First of all, good evening, sir. Good evening, ma'am. Thanks for
Good evening.
Yes,
organizing this
sir. Yes,
FTP.
ma'am.
Actually, this was complete. This was a completely well organized FTP. With more than that, your response for our queries was incredible. With so much of patience from us regarding our queries, and it is a great part to be of this FDP. With gaining knowledge on the trendings among the globe, such that everything has been normalized with the AI, and everything has been connected with the internet, everything. So that's so our civil too. And overall, it was a great experience learning from the resource persons, ma'am. Thank you once again, ma'am.
Thank you, ma'am.
Thank you
Your
very
name,
much.
Kalaimathi, I'm actually extremely sorry, difficult to pronounce for me. Kalaimathi
It's
ji,
okay.
what is being shown here. Thank you, ma'am, for your feedback.
Thank you, sir.
Dr. Ashish would like to give their feedback. Dr. Ashish, uh, if you can start your camera, that would be great. Dr. Ashish, am I audible to you? Dr. Ashish. Dr. Ashish raised their hand, but uh, okay, anyone
Okay,
else who would like
so
to give their feedback?
Saran Chandra, sir.
Shravan Chandra ji, he wished to give his feedback.
Yeah, good evening, one and all. And it was a great session. And I have learned a lot with the help of resource persons. I am very much thankful to Atal and your organization. So simply superb. The FDB was very much like interactive sessions and all. It was very much informative for me. I have learned a lot from the resource persons. I'm very much happy. Thank you.
Thank you, sir. Thank you very
Thank
much,
you,
Shravan
sir.
Chandra ji. Uh, Pragati ji want to give their feedback. Pragati ji, uh, your voice is Pragati ji.
Yeah.
Your
My
voice
voice is
is being
audible now? Yeah.
audible to. Yes, yes. Now it's audible to all.
Yes, yes. Thank you, the whole team, for giving the wonderful opportunity to be the part of this FDP. From the day one, all the organization was beautifully handled by Kamlesh sir, and every query was handled by Kamlesh sir in a very good manner. And we are thankful to the complete team of this FDP. Talking about the session were great. All the people, all the dignitaries who have been called for giving the session look like the experience in their field. So we gain lot of insight from it. However, I was completely unaware about this smart city and infrastructure facility that would evolve in nearby future in India. But I am thankful to this FDP. That was my first session, introductory session, for understanding the basics of the smart city. Thank you so much.
Okay, thank you,
Thank
ma'am.
you,
Thank you
ma'am.
very much, ma'am. Dr. Manchikant
Manchikanti, sir.
Srinivas want to give his feedback. Srinivas, sir. Sir, your voice is not audible to us.
Good evening, madam. Good
Good
evening,
evening, sir.
Kamlesh ji.
Good evening, sir.
Very nice. My name is Dr. Manchkan Srinivas, Professor of Civil Engineering, Gayatri Engineering College, Visakhapatnam, Andhra Pradesh. And I thoroughly had an enriching experience with respect to the various sessions which were carried out and which were held during the FDP. And I have some very favorite sessions. Can I mention those favorite sessions
Definitely,
also, names
definitely,
also?
sir. Definitely, sir. Definitely,
Sure,
definitely.
sir, sure.
Yeah, my
Yes,
favorite
yes.
sessions were basically AI in traffic and transport systems by our Dr. Agnivesh. And another my favorite session is Introduction to Urban Sustainability by Sanjay Mehta ji.
Okay, okay. Yes, 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 yes.
And I have another favorite session that data-driven privacy is there, na, by Dr. Chetan
Yes,
Sharma.
sir. Yes, sir.
That also I liked very much,
Okay.
very much. And anyway, Arun Vyas sir lecture also was very good. That first one, the smart cities one, that was also very good.
Yes,
And
yes,
with
sir.
respect to the final one, that another one which I liked very much was the Dr. Praveen Kamath
Kamath,
presentation.
sir.
The citizen centric services is there, no?
Yes, sir. Yes, sir. Yes,
That
sir.
was so good. All these
Yes.
are like, I mean, I'm not saying other lectures are not good, but these I liked very much.
Definitely, sir. Thank you, sir. Thank you very much. So, any suggestions from your
Thank you,
end?
sir. Thank you.
And our and in our speaker, if I remember correctly, Dr. Agnivesh, he
Yes,
has
sir.
also
Yes.
sometimes in between he provided some online polls also, if I am not mistaken. If I'm wrong, please correct me.
Dr. Chetan provided the online
Oh,
polls
sorry,
Chetan
on.
sorry,
Sharma,
sorry,
sir,
sorry, sorry.
provided.
I think it's Dr. Chetan.
Yes, yes,
Chetan Sharma, sorry. Sorry for that. So I like those polls also, All
yes,
these
yes.
polls are also, they keep you alert. They
Definitely,
keep you
definitely,
focused
definitely, sir.
on the presentation.
You have been
So,
the most active participant, sir. We have found you discussing every time, posting the questions on behalf of yourself and on behalf of all other members also. That was very helpful.
thank you very much for the wonderful sessions. And I am very much happy. I will be taking up this course next semester. So I have got enough, I'll get enough
Thank
information
you.
from this, and I'll take up this course next semester. Thank you. Thank you to
Definitely,
all the
Srinivas.
wonderful
Thank you.
Thank you,
organizers,
sir.
and thank you very wonderful speakers and wonderful resource
Sure, sure.
persons and wonderful participants. Thank you, Kamlesh ji. Thank you,
Thank you,
Madam
sir.
ji. Thank
Thank
you
you.
for your excellent coordination. Thank you, ji. Thank you.
Thank you
Thank
very
you.
much, sir. Thank you,
Thank
sir.
you.
Thank you, sir.
Thank you.
Thank you.
Thank you.
Sangeeta ma'am, would you like to give some feedback? Sangeeta ma'am, you're on screen. It would be great if you can say a few words about this FDP. Your voice is not audible to us, ma'am. Ma'am, your voice is not audible to us, Sangeeta ma'am. Are we audible to you, ma'am? Sangeeta ma'am, your voice is not audible to us. I think it's muted. Okay.
Hello.
Yes,
So, Dr. Ashish Ladda, sir.
Dr. Ashish would like to give their feedback. Uh,
Good evening to the organizing team. First of all, I would like to congratulate you for organizing such a nice FDP. All the sessions have been very informative, covering the various aspects of AI in the organization. Uh, the topic, session expert presentation, everything has been so nice and very well gone. So I liked all the sessions and learned so many things. And I would expect more such FDPs are going to be organized in future from the organizer's end.
yes, sir. Yes, sir. Uh, as I
Thank you,
remember,
sir.
Dr. Ashish, you are also organizing an FDP.
Yes, sir. At
Yes.
our Department of Applied Sciences, Purnima Institute of Engineering and Technology is also organizing one FDP entitled Preserving Local Dialects Using Multi-Layer Perceptron for Sustainable Development of Communities. So
Okay, okay, okay.
all those people who are who want to join, they are encouraged to join next week, 20th to 25th January 2025.
So how they can connect with you? How can we
Yes,
get know more about the FDP?
sure, sir.
Like it is Atal FDP. Will they find on the
Yes, sir.
Atal portal? Okay, okay. On the
Yes,
Atal portal,
yes,
they
sir.
can find the FDP. Okay, okay. Sure, sure. So participants are requested to join that if they find time, convenience, relevance. Uh, Anyone else?
Sir,
Thank
may
you, sir.
you may share the link of the brochure of your FDP here in the
If there is anything, any link
Okay,
type, you
ma'am.
can share in the chat box.
Yes, ma'am. I'm going to
yes.
share in the chat box.
Yes, yes, yes.
Okay.
Uh, Anyone else? Thank you, sir.
So
Thank
thank
you
you,
very
sir.
much, Ashish,
Thank you,
sir.
Ankit, sir.
Okay.
Ashish, sir.
Thank you, sir. Thank you, ma'am. Thank you, the whole team.
Thank you very much. Anyone else who would like to give their feedback?
Hemant Kumar Upadhyay, sir.
Good evening. Good evening,
Uh,
ma'am.
Vidya ma'am is giving her feedback.
Yeah, ma'am.
Good evening, ma'am. Good
Yes.
evening, sir. The
Thank you,
program
ma'am.
was highly informative and well
Good evening.
organized, and it provided valuable insights to the intersection of AI, sustainability, and urban planning, sir. The session were engaging, and the speakers were experts in their field, sir. I gain new perspective of knowledge will enhance my teaching experience and research capabilities. Thank you, organizing committee. Thank you, ma'am. Thank you,
Thank you.
Kiran, ma'am, and thank you, sir.
Thank you.
Thank you very much, Vidya ma'am,
Thank you,
for
ma'am.
giving your feedback. Uh, Sangeeta ma'am, would you like to give feedback? You are active.
Hemant, sir.
Uh,
Hemant, sir.
Hemant sir. Okay, Hemant sir.
Good
Yeah.
evening.
Yes, Hemant, sir.
Good evening, sir. Good evening, madam. I admire the collective
Good evening,
effort
sir.
of your team, convener, coordinator, sir, coordinator, madam, co-coordinator, sir, and I express the gratitude to the management of JIT Group of Institution for organizing this Atal FDP in the evening session specifically. So we could focus on that, and we could get so much informative knowledge from this. Thank you, sir.
Right,
Thank you
right,
so much.
sir.
Thank you, ma'am.
It was organized in the evening so that everyone can find some time. Otherwise, during we all are faculty members and we have our engagements in classes and a lot of interventions are there. So at least we can attend peacefully.
Definitely.
Thank you, sir. Thank you very much.
Dr. Lakshmi Chaudhary, ma'am.
Hello. Good evening, ma'am.
Yes,
So
ma'am.
am I audible? Uh,
Yes,
so
ma'am.
uh,
Please turn on all your camera.
I think a little.
I also want to share my feedback. First
Sure,
of all, I
ma'am.
want to thank
Yes, ma'am.
Atal FDP and HOD ma'am and Kamlesh sir for organizing such a wonderful event. And I have gained a lot of experience from the resource person. And thank you so much, ma'am and sir, for organizing such a wonderful event. Thank you, sir. I am from West Bengal.
Okay. Definitely, ma'am. This is the platform where people from all across the India can come upon and join. Uh,
And thank you so much for your patience level, sir and ma'am both.
Definitely. India is a country of
Thank
diversity, and
you.
we are
Thank you
seeing
very
this
much.
diversity here also. Thank you.
Okay.
Thank you very much, ma'am.
Thank you, sir. Thank you, ma'am. Thank you
Thank
so
you.
much.
hello.
Ma'am, yes, you want to
Yes,
share?
Uh, so good evening, everyone, whoever with the participants, and I'm also from JIT, from Electronics and Communication Department. So basically, this till date we thought that the AI or the whatever the technologies are being used will be in the form of the embedded system or robotics. But this time we came to the live experience and real time examples what the experts has shown that how it can be used for environment monitoring and even in the energy efficiency, sustainability environment, and how all these things can be used for the latest technology can be used for making the smart cities. So that is a very because where we are living that is more important, and in front of that we will be seeing that AI implementation with the best optimization will be helpful. So session, all the sessions were very beneficial, and some of the knowledge as the field was like integrated of civil and AI, computer science. So this will help us to make the new application areas. Thank you so much, ma'am.
Thank you, Lakshmi ma'am, for your
thank you,
valuable
ma'am. Thank
feedback.
you very much.
I did acknowledge you in the environment session. Uh, okay, anyone else who would like to share their feedback? The stage is open for everyone. We had many valuable feedbacks from audience from different parts of the country. Anyone else who would like to give their feedback? There are many people who are active. Sanatan Lakshya ji, Ketan ji, Shakshi ma'am, Manoj Pradhan ji, Rituraj ji, Umesh ji, Priya Shekhawat ji. So Naveen Porwal ji is replying in chat box. He don't want to appear on the screen. Thank you, Naveen ji, for your
Ankita
valuable
ma'am.
feedback.
Okay.
Ankita ma'am also. Okay, so ma'am, we
Kamlesh sir,
can speak, yes ma'am.
it's time
Yes ma'am, we
to
can finish the
share
feedback
the
and we can
feedback
start the
to
validity.
Atal portal.
Yes ma'am. So ma'am, a few words from your end, Kiran ma'am, regarding the AICT workshop, this workshop.
Uh, Sir, validity in the validity. Uh, I will share some thoughts from my side. Uh, this time, all the participants will fill the feedback through Atal portal.
Yes, the feedback link you will find in the Atal portal. You will log in there and you will on the left hand section you will find the feedback and there you can fill the feedback. Feedback is compulsory on the Atal website also. I believe all of you have given the test. If you face any difficulty in opening the quiz, that is the assessment test, do ping me personally. We'll look into the issue and after this 6 day long FDP coming to an end, I'm really happy to see people all across the country. मेरा भारत मान जो जो हम लोग बात बोलते हैं आज उस भारत को देख भी रहे हैं हमेशा जो इंडिया की बात सिर्फ हम लोग बातों में करते हैं पर आज जो ऑलमोस्ट इंडिया यहाँ आ चुका है क्योंकि हमारे पास 16 स्टेट से जो है प्रोफेसर रिसर्च स्कॉलर्स हैं and the experts were from India and outside India. So very happy to engage with you all, to connect with you all. We'll start the uh, validity session in just a couple of minutes, and you can send your emojis to congratulate me and Kiran ma'am for this FDP.
Manchikranti sir is
At times,
sharing
something to
lots
learn from
of.
Modi that something to learn from Modi that we need to appreciate everyone who put the effort.
Yes,
It
Ketan
was very
Jangir sir.
exhaustive. Ketan,
Sir,
you want to express
Ketan
something?
Jangir sir has raised his hand.
Yes, yes. And Shishir Dubey ji also.
And
The
she
mic is on,
sir,
Shishir, you
yeah.
can speak.
Siri sir, please open your mic. Siri Dubey sir, you want to say something? The valedictory program will start within few minutes.
And in fact, I would also like to share that we should be thankful to our family members also who have cooperated us in attending this FDP, in organizing this FDP. Uh, bringing everything on the table: food, coffee, tea, and their support, especially by the ladies and all those ladies who are working there. Thankful to their family members who supported them. It's very difficult for a lady to engage in two tasks simultaneously, and that's why she's called as multi-talented. Ladies are always multi-skilled. They can do more than one task at a time. So thanks to all the family members also who supported us in this journey of 6-day online FDP. Srinivas sir has given a thumbs up. He knows the value of things on the table. Yes, sir. Yes, sir. So, Sarman Chandra is also enjoying the same privileges. 4 minutes to go. Yes, sir. You can say if you
Sir,
want.
good evening, sir.
Yes,
Hello,
ma'am.
sir.
Yes, ma'am.
Sir, I'm not able to do the assessment workshop, sir.
That Google form is not opening.
Yes, sir.
Let me check. We have received 80 responses. Like, what is the issue? Could you like what it is saying?
Sir, it is not opening, sir. The link is not opening.
Ma'am, it requires an email address to fill the Google form. So you have to log in first. So is your
Yes, sir.
browser
I
open?
already have logged in and give the feedback form already. So once attendance, after that assessment is the column is there. I have opened the assessment.
Okay, you are asking on the Atal portal.
Yes, sir.
Okay, ma'am, that is
Test link
something.
is not opening, sir.
Okay, ma'am, that is beyond our control. You can try again, maybe in the late night or tomorrow morning. That is open. There is no hurry to give the
Okay.
feedback on that. There is sufficient time.
Okay. Okay, sir.
Because
Okay.
that may
Thank you,
be
sir.
some issue at the Atal website, and that's not in our control, ma'am.
Okay,
Okay.
sir. Thank you, sir.
Okay. Dr. Srinivas, you would like to share something? You have raised your hand.
Yeah, yes, Kamlesh ji.
Yes, sir. Yes, sir.
Yes. The whenever I was just mentioning about Chetan Sharma ji's lecture also, no, there he was making the lecture engaging by also sometimes making sure that people don't sleep. Well, people not sleep anyway. But then by polls he used to do now.
Yes, sir. Yes, sir.
So in my lectures, when I deliver lectures online, also I also use this feature
Yes, sir.
to
That's a
ensure
great way of engaging the audience. You at least keep them aware.
you don't. So when you put all these polls, because in all my online lectures, whenever I go to FDPs, I ensure that when at least I conduct 4 to 5 polls in between my lectures, so to ensure that they are there with me.
True,
They're
true,
not.
true, 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 sir.
So that is what. So I like this. Like I was able to connect with him much
Yes, sir.
better. Is what I'm trying to tell you.
Just to supplement this knowledge, Slido is a way we can conduct online quizzes and online polls. And in
Correct.
addition, this Google Meet also have a feature in which we can conduct poll through Google Meet also. But for
Correct.
that,
Correct.
yes, but for that, pre-preparation is required. Our experts are joining at a short on last moments, and they are more consumed in the research works. They might not be very much conversant and friendly with all these polls. So,
True, true,
all
true.
challenges are there in organizing FDP. At times, last moment, we have messages from experts that he is unable to take, and then we have to some firefighting provisions. So, all the issues we face. Uh, but anyhow,
I
in
understand.
FDP discourses, we try to do what best we can do.
No, you have done, you and madam and their entire back office and the entire team have done a wonderful job. I know what it goes into conducting FDPs because I've conducted so many FDPs. Every
Yes.
FDP is like, a big challenge. Even though we have
Even even
loads
for
of
the
skills.
even for the attendance, we shared the Google form so that no one can miss that. But still, some few people, they were not very in touch, and that's why they couldn't fill the Google form. So we
Hmm.
try our best, and
Hmm.
even like filling the attendance is not difficult, very easy. Kiran ma'am knows very well to mark a single attendance presenter. You have to
Hmm.
click 4 times, and all that processing time in one click and between the clicks.
Correct, correct.
So very exhaustive. Almost she had spent 3 to 4 hours in filling the attendance itself.
I
So
understand.
thank you to Kiran ma'am for so much of exhaustive work.
But then it's great job done by the organizing committee. And my only point is, that you all should, you and Madam G and other team should take a holiday. Okay, don't go to some place far from work and have a great time. Madam G, you, Kamlesh G, and your team. It's recording. Oh God, it's in record mode. Okay, fine, it's okay.
We would
I
love this
recording is
thing
on.
if we had some any such type of privilege.
So just you have to relax 1 or 2 days. You have to go somewhere and you know
Our
or from
our
this
our dean
man.
sir is about to join. You may suggest them. So can we start, ma'am?
Yeah, yeah.
Yes, sir. All the dignitaries came and joined in this meeting. So we are going to start the valedictory program. So respected Dr. Vidit Mehta, sir, Dean Faculty of Engineering and Technology, Chief Guest, Dr. Anuja Sharma, madam, a scientific officer at Center of Emerging Technologies and Sustainability at IIT Jodhpur, HODs of all the respective departments, and esteemed participants. Very good evening to all of you. It is an honor and a privilege to welcome you all to the program of the Atal FDP program on AI urban futures, advancing sustainability in smart cities. Over these 6 years, 6 days, we have embarked on a journey of knowledge, collaboration, and innovation. This FDP has provided us with a platform to explore new ideas, share valuable insights, and gain a deeper understanding of use of AI in smart cities. The active participation and engagement from all of you participants have made this program a resounding success. As we gather here today to mark the conclusion of this enriching initiative, let us celebrate the knowledge we have gained, the ideas we have exchanged, and the personal connections we have built during this journey. Once again, I extend a warm welcome to each of you and look forward to a meaningful and memorable conclusion to this program. I would like to invite Dr. Vidit Mehta, sir, Dean FET, for words of wisdom. So, Vinit Mehta, sir, mic is over to you, sir.
Thank you. Thank you so much, ma'am. Am I clearly audible?
Yes, yes, sir.
Respected Chief Guest, Dr. Anugya Shukla, Scientific Officer CETSD IIT Jodhpur, Dr. Kiran Booth, the coordinator of this online FDP, Engineer Kamlesh Parihar, the co-coordinator of the online FDP, all the heads, faculty members from our JIT Institute, and dear participants. First of all, I would like to extend a warm welcome to the chief guest today, uh, Anugya ma'am, for sparing valuable time from her packed schedule. I would like to congratulate
first of all, Kiran ma'am and Kamlesh sir for conducting this worthy online FDP on AI powered urban futures, advancing sustainability in smart cities. Uh, when we talk about the smart cities, obviously we think of a place which is better than a normal city. In terms of infrastructure, in terms of buildings, their plannings, malls, traffic control, population, pollution, everything. And when we keep the sustainable development in mind, it is expected to make optimum utilization of the resources so that they are not getting exploited. Uh, Participants, I am looking forward for that future where in morning when we heard from the garbage collector, गाड़ी वाला आया देखो कचरा निकाल. He will take the garbage himself with the help of AI and I don't have to get up. So overall, such smart cities are all about enhancing the quality of our living style. For this, AI can be a game changer. AI in traffic management can be a game changer for reduction in travel times. AI in waste management can also be a good play a good part for controlling the carbon emission and better air quality. Also, AI can be a good contributor in public safety. When we talk about ambulance system, that can be a smart system, fire brigades, smart fire brigades, and predictive policing algorithms can also be implemented. So, in last, I would like to say and conclude my words by saying I am very happy that this FDP has touched all the aspects of making a sustainable future by implementing AI for smart cities. I once again congratulate all individuals who were directly or indirectly the part of this FDP. Thank you so much, ma'am. Thank you all.
Thank you very much, sir, for your words of wisdom. I would
Thank you,
like
ma'am.
to invite now. I would like to invite Professor Kamlesh Parihar to give report on this FTP. Sir.
Thank you, Kiran ma'am. Uh, Very good evening, everyone, on this cold night. Uh, our esteemed chief guest, Dr. Anugia Shukla, Scientific Officer, CTSD, IIT Jodhpur, Dr. Vineet Mehta, Dean Engineering, JIT Jodhpur, Dr. Kiran Booth, HOD Civil, faculty members of the JIET fraternity, and distinguished educators from universities and colleges across India. It's an honor to welcome you all on this occasion from the sun city of India, that is Jodhpur, known not just for its rich culture but also for its delightful sweets and savours, especially namkeens. We have gathered here to reflect on the success of our 6-day online FDP AI powered urban futures advancing sustainability in smart cities. This event witnessed overwhelming participation with 170 plus attendees from 16 states across India. We can see all India here together. Throughout the program, we have conducted 13 engaging sessions delivered by 11 accomplished experts from academia and industry. They were marked with the inauguration of the FDP, where Professor Dr. Kiran Booth opened the program with a warm welcome address. We were privileged to have Dr. Ashish Verma, convener of IIC Sustainable Transportation Lab and professor at IIC Bangalore, as our chief guest. His inspiring speech on the critical role of AI in urban development, difference between standard of living and quality of life, set the tone for the program. Following this, Dr. Avnish Bora, Director JIT, shared his insights, emphasizing the importance of AI in shaping the cities and their future. Then Professor Kiran Booth introduced the theme and schedule, officially launching the FTP. The sessions began on day one with Mr. Arun Vyas, who took us through an insightful session on introduction to smart cities using the case study of Udaipur. He highlighted how AI is enhancing city services and transforming urban management. This was followed by Dr. Govardhan Bhatt, who elaborated on AI and energy efficiency in smart cities, showcasing how AI can optimize energy use and promote sustainability through real world case studies. Day 2 featured uh, thought-provoking two thought-provoking sessions. Dr. Agnivesh spoke on sustainable urban mobility, discussing how AI is revolutionizing traffic and transportation systems with the data. Next, Dr. Chetan Sharma, joining from the University of Texas, delved into the concepts of AI in circular economy. He explained how this approach can reduce waste and environmental impacts, particularly for the densely populated country like India. Day 3, marked by Engineer Sanjay Mehta, presented a session on urban sustainability, addressing the growing pressure of urbanization on resources. He highlighted sustainable urban planning and innovative solutions to challenges like waste management, climate change, etc. Next session, Mrs. Smita Jaiswal discussed how algorithms works in AI and machine learning and how models can be created by collecting the city data. They can AI models can be trained using the data and then they can be used for urban sustainability. Moving to day 4, Professor Saran Adar delivered an enlightening session on AI for climate action. He demonstrated a case study of Jodhpur and how AI-driven digital twins can be address issues like flood management, pollution control, traffic optimization, etc. In next session, Engineer Sanjay Mehta took us through the AI in disaster management, illustrating how AI can predict disasters, assess damage, and formulate mitigation strategies. Day 5 begin with Dr. Praveen Kamath, a fire engineer from Holmes, Australia, New Zealand, Sydney, who explored citizen-centric smart city services with AI. He discussed how AI can aid in fire detection and rescue efforts alongside fire-resistant technologies. The day concluded with Dr. Chetan Sharma, who presented a AI-driven data governance and privacy model. Using a case study from Switzerland and discussing the policies of Government of India, he shed light on how AI can be used with data security while safeguarding the citizens' right. The last day of the FDP, the day 6, encapsulated sessions from Dr. Manish Goyal, Chair Professor and Dean Infrastructure at IIT Indore, Professor Dr. Deepak Swami, Associate Professor at IIT Mandi, and Professor Prasanta Sahu from BITS Pilani, Hyderabad. Professor Manish discussed the resilience of river basins of India in context to climate resilience, land use resilience, plant resilience, etc. Professor Deepak Swami discussed how pollution has entered in our daily life and how to mitigate it. Through their project work, they enlightened the audience about the impacts of pollutants on health of citizens. Professor Prasanta discussed the implementation of AI in urban mobility in creating livable cities, which are equally important to smart cities. This FDP has been an enriching journey, offering valuable insights, opening up the new horizons, intersections of AI and urban sustainability, etc. These sessions were engaging, thought-provoking, and packed with actionable knowledge that all participants can carry forward in their professional endeavors. Thank you all for your active participation, enthusiasm, which made this India a remarkable success. Let us continue to explore and innovate as we envision a smart, more sustainable, and urban future. Thank you. Jai Hind.
Kamlesh sir, can the feedback link shared here in WhatsApp group or
Feedback is on the Atal website. You can go there and start it. Kin ma'am, we can proceed with the session. Hello.
hello
You
sir,
are on.
did you got me? Can the feedback link shared here?
No, ma'am, we cannot share here.
Okay, we have to
Anyhow,
fill compulsory from portal.
You have to log in and give your feedback.
Okay, sir. Okay.
Kin ma'am, your voice is not audible. Maybe some connectivity issue.
Yes, sir. Yes, sir. Yes, sir.
Hello.
Now, thank you, Kamlesh sir. I would like to invite Dr. Anugya Shukla, madam, chief guest of this event. She is a scientific officer at the Center for Emerging Technologies for Sustainable Development, IIT Jodhpur. She holds a PhD in geomatics engineering from IIT Roorkee with a specialization in geospatial technologies, urban climate, and disaster risk assessment. Additionally, she has postdoctoral research experience from IIT Bombay. Her expertise encompasses UAV data applications, sustainable urban planning, and 3D heritage mapping. An active mentor and reviewer, Dr. Sukla has published extensively in high impact journals and has contributed to initiatives promoting innovation in geospatial and climate resilience research. Uh, Dr. Anugia ma'am, uh, mic is over to you.
Thank you, ma'am, for the introduction. And first, I
Ma'am,
would like to. Am I audible?
yes,
Yes, ma'am,
ma'am,
you are
please turn
audible,
on
ma'am.
your camera.
So, first, I would like to thank the organizers for inviting me to the conclusion of this FDP, that is on AI powered urban futures, advancing sustainability in the smart city. As I heard from Dr. Kamlesh, that so many of my colleagues also have given lectures from IIT Mandi, IIT Indore, and from IIT Jodhpur, and so it was very nice to listen that so much of applications of AI in the different
Yes, ma'am.
aspects has been covered in this FDP. So
Ma'am,
I,
excuse me, ma'am.
yeah,
Please turn on your camera.
yeah, sure. Am am I visible now?
No, ma'am.
Okay,
Yes, yes,
Yes, ma'am.
yes,
okay,
ma'am. Yes. Thank you very much.
yeah,
Thank you.
sure. I hope over the past few years you all would have embarked a journey of knowledge sharing, collaboration, and also would have explored the transformative potentials of AI in sustainable urban environment. As there's an urgent need for smart and sustainable cities across the world, especially if we look at the India. The cities are now become an epicenter of economic growth and human development. So this rapid urbanization is also bringing us with a new challenges like rising pollution, resource depletion, inadequate infrastructure, and another the important factor is that climate change is also accelerating these issues, such as generation of with few centimeters of rain, millimeters of rain, we get flooding situations in the city, how to deal with them. So AI has emerged as a vital tool now that offers our transformative solutions for urban planning, resource management, and citizen services. By using the AI, we can now create cities that not only are smart but also sustainable. And our role as an educator and researchers become quite vital in this transformation. So I hope this FDP have equipped you with cutting edge tools and methodologies that advance research and inspiring students and contribute to the real world problems. So, before I conclude, I extend my heartfelt thanks to organizers, speakers, and facilitators for their invaluable contribution. As I can see, there are a lot of participants over there. So, this embarks the success of your FDP. And I also commend the participations for their enthusiasm and active engagement. As I joined, I can see a lot of people are interacting, they are asking for different things. So I think this is great to see that such a good program has been happened and taken by you people. So I thank you and I wish you all in your future endeavors. Thank you, ma'am, and thank you all.
Thank you, ma'am. And I would like to share that we both share the same alma mater.
Okay.
My MTech is also from IIT Roorkee.
Oh, that's great.
Deepak sir is
Okay.
my senior, and currently I'm also pursuing a PhD from IIT Jodhpur under
Okay.
Dr. Amit in civil
Okay. I'm
department.
from Civil Department, Dr. Ramesh Sharma. Okay.
That would love to meet you whenever I will visit
Yeah,
there.
yeah, sure. You please visit. We work in collaboration with Dr. Amit, Dr. Saran.
Sure, sure, ma'am, sure.
Yeah. Thank you so much. Thank you, ma'am.
Thank you, madam. Thank you.
Thank you.
Uh, Now, I would like to invite Dr. Abhishek Arya, sir, HOD Administration, Department of Civil Engineering, JIT. Professor Abhishek Arya. Professor Arya?
Yeah.
Yes.
Am I audible?
Yes, sir, you are audible.
And eventually, am I visible?
Ah, sorry, your camera is
Sir.
not on.
I'm trying my best. Am I?
No, sir.
Still not.
See, I'm trying my best.
Yes,
Finally,
yes.
yeah, I am
Yes,
here.
yes,
Okay.
yes, finally.
Thank you so much, Kiran ma'am, for inviting me to deliver the vote of thanks for this 5 days FDP. So, good evening, all participants. Good evening, Anupriya Shukla ma'am. Good evening, Dr. Vinit Mehta sir. I am Dr. Abhishek Arya. Uh, as we conclude this enriching 5 days faculty development program on AI-powered urban features, advancing sustainabilities in smart cities, I feel privileged to express my heartfelt gratitude to everyone who has made this event a success. First and foremost, my sincere thanks to our esteemed resource persons, speakers, whose invaluable insights and expertise have illuminated the path toward building smarter and more sustainable urban landscapes. Your contributions have been truly inspiring. Now, I extend my gratitude to the organizing committee, especially Dr. Kiran Booth, HOD Mentor, Civil Engineering Department, JIT. She has worked day and night for this FTP. And special thanks to Professor Kamlesh Priyar sir. His hard work, his dedication and his one-liners are very special, and they have not only made us enlightened about the subjects and everything, but have entertained us as well. Thank you so much, Dr. Kiran Booth ma'am and Professor Kamlesh Priyar sir, and also dedicated team behind the scenes, the department, all the faculties and the staff members, as well as the people who are related to the network things as well. So thank you so much to all the team. To our participants, thank you so much for your enthusiasms and active engagements. I can see completely on the in the WhatsApp group as well. Regularly, people are there being engaged. Where they are WhatsApping, they are giving messages, and then also in the lectures as well, people are asking questions. In the feedback also, there were a number of people who has given their so good feedback, so positive feedback. So it shows that, and this is actually the success of such type of programs. And the diversity, I can see so many states are there. There are participants from various states, and as said by Kamlesh Priyar sir, so this is really, really nice. So thank you so much to all the participants for that much interaction, that much enthusiasm which you people have shown, which has made this program an interactive and meaningful learning experience for everybody. Lastly, I express my deepest appreciation to our institute. We are having Dr. Vinit Mehta sir here, who is representing the management. So thank you so much, Vinit sir. On the behalf of Civil Engineering Department, I thank you and the whole management for your unwavering support and vision in fostering such initiatives that contribute to the academic growth and societal development. I request all the participants to let us take forward this knowledge and ideas shared during these 5 days and work collaboratively to shape the future of sustainable urban living. I thank you all and I wish you everybody for your continuous success in every endeavors you are engaged. Thank you. Thank you so much.
Thank you very much, Dr. Abhishek Arya sir. And thank you very much to the wonderful, excellent, enthusiastic, disciplined participants. Thank you very much. And I would like to invite all of you to visit JIET when you come to Jodhpur. We welcome any collaboration in the form of projects and summer training from your side. We are open for that. Thank you. Thank you very much to
Ma'am,
all of
one line from my end. Although I
Yes,
have
sir.
said it earlier, but
Yeah, I'm
thanks
waiting
to
for
all,
that. I'm waiting
thanks
for
to
that
all
one line.
the, thanks to all the family members of all the participants who have coordinated and supported them in the evening sessions when everything is going at home and they do support. So formal thanks to them also. Thank you, everyone.
Thank you. Thank you.
Thank you, Nukia ma'am.
Thank you, ma'am.
We all can leave. If any information is there and update is there, we'll share in the WhatsApp group.
One more announcement. to all the participants. uh, you can